going to put on there is called Raspbian, what that is derived from the name Debian, but it's for the Raspberry Pi. Basically, it's a type of Linux. If you haven't heard of Linux, then don't worry, it won't scare you. It's going to be fine. So let's have a look at, here are my instructions. That's what you need to buy. It's going to cost you about 47 quid overall. And you need to get Raspbian onto your SD card. So I'm not going to go into a great deal of detail about how to do that. There's a couple of websites that I've linked from the blog post on it. Basically, you go to the Raspberry Pi page, which is here, scroll down and have a look where it says Raspbian Wheezy, direct download, download that zip file, and then follow the instructions, which I've also linked from the blog post, telling you how to set it up. There's all kinds of instructions for Windows, several different versions for Windows and for other things like that. It's all going to be fine, honestly. So once you've put your image on your SD card, and don't forget, by the way, all this stuff is cheap, so if you mess it up, even if you break it, it's not that bad, but it's very difficult to break it. But if you mess up your SD card, just do it again. All you have to do when you're following the instructions is not wipe your computer, okay? So be careful about that. That's probably easy to do if you're on Linux. If you're on Linux, then definitely don't wipe your computer, okay? If you're on Windows, maybe it's not so bad. Okay, so once we've got all that stuff, we've plugged all the cables in the little holes that I've shown you. Plug it into your TV. When you plug the power in, it turns on. So basically, there's no on-off switch. You just plug the power in and turn it on. And you're going to see some screens that look a bit like this. It's going to boot up. It's going to take a while. You're going to see a lot of white writing. Don't let that worry you or anything. You don't have to understand any of that. And then the first thing you're going to see is there's going to be a setup page. Just ask you a few questions before you get started. I was going to tell you what buttons to press on this page, but actually I didn't need to press anything on that page at all. Maybe you won't either. Certainly if you're worried by that page, don't worry about it, just carry on. What you can do is press tab and then press the right arrow and then return to get onto the finish button. Once you press the finish button, you wait a little while longer. You're going to get a big raspberry in the middle of your screen and a mouse pointer. If you've got your keyboard and mouse plugged in, you ought to be able to move your mouse around, click on stuff, have a play with that. If you mess it up, don't worry, you can just redo the SD card, so you can't do any harm. And once we've got that all set up, we can start writing a game. And the first real episode of this is going to be the next episode, where I take you through very, very slowly a very, very simple game, which is going to make your Raspberry Pi into a games machine, and it's going to make you into a games programmer. Hi, my name's Andy, and this is part 2 of my first Raspberry Pi game. We're going to write the simplest possible program we can write today, a program that just says hello to you. If you missed out on the first part, that's how you get hold of a Raspberry Pi, how to get it set up so that it looks like how it's going to look when we look at it in a second. Today we're going to cover things like basically what is a computer program, how do you run one, how do you write one. So if you followed part 1, you should have a Raspberry Pi that has a screen that looks a bit like this, with a great big raspberry on your TV, and you've got a mouse and a keyboard plugged into it so you can control stuff on it. Your Raspberry's probably gonna look smaller. Everything's probably gonna look a bit smaller on yours, unless your TV is quite small. I'm quite zoomed in on this screen, but it's the same. Everything's the same, really. So the first thing I'm going to do, assuming you've got this Raspberry Pi screen all set up, is we're going to write our first computer program. We're going to jump straight in and do it. So what do? Well, you go down here, click on this weird little aeroplaney thing, click on accessories, and then LeafPad. And LeafPad is a text editor. That means an editor in which you can write text, you can write writing. So you don't need to do this, but the first thing I'm going to do is make the font bigger so you can see what's going on. So you might find the font's fine how it is, but that will help me. So now I've done that, let's write our first computer program. You need to type exactly what I type. A bit later on I'll show you what happens if you type it wrong, but for the moment try and type exactly what I type. So what I'm going to type is print, and then a double quote, which is over the number 2 on my keyboard, or possibly over near the return key on yours. And now I'm going to type hello world, exclamation mark, and then a closing quote. That's our program. That's it. It consists of this word print, which means write something to the screen, and this stuff in quotes, which is the argument that we pass to the print statement. An argument just means some information you're giving to the command, and the information we're giving here is, what do I want you to write to the screen? I want you to write this message, hello world. So we go to the file menu, save as. The place we want to save it is in our home folder, which is called Pi, because our name on this Raspberry Pi is Pi. So click on the Pi, type in the name, and because the game we're going to write is going to be called Red Green, I'm going to call this redgreen.py. So the red green part is the name of it. Notice that there's no capitals or anything, just to make my life simpler. No spaces, nothing like that. And then there's a dot, and then there's py, which means this is a program written in the programming language Python. We'll find out more about Python as we go on, but all you need to know for the moment is that it's a language in which we can write programs. And the reason why print and then that hello world string that we wrote works is because that's the way you can write commands in Python. So click save. Now we've got a file on our disk called redgreen.py, which is in our home directory, and now we want to run it. So what do? We go back to the weird aeroplaney thing, click accessories, and then click on this program called LX Terminal. There's also another button. You could double click in the top left instead if you want to. Now again, just to make it easier for you to see, I'm going to make the font on this window a lot bigger, which you may or may not want to do yourself, but it's going to make our lives easier. So there we go. Now, a terminal is a program which runs other programs. So this terminal is the program we're going to use to run our program. And the way we run our program, the way you run any Python program, or one way, is you type Python, which means run the program called Python, which runs Python programs, and then we give the name of our program. We're already in our home directory, so we can just type the name of our program, which is redgreen.py. So what we're saying is, run a Python program, and the name of the Python program I want you to run is redgreen.py. When I press return, our program runs, and what our program does is exactly what we told it to do. It writes to the screen, hello world. So well done. We've written our first ever program, and it did exactly what we expected it to do. If you type something wrong, you might get some other messages. So I'm very quickly going to show you what might happen. If you type the name Python wrong, for example, you added some extra numbers here, so Python was spelled wrongly, and then press return, it would say that. So if you type Python wrong, it will say command not found, because it doesn't know what Pyt 546 hon is, but it does know what Python is. Also, if you gave the name of your program wrong, for example, let's imagine you put a space in there, then it's going to say, I couldn't find that file, I can't open that file. So that's what it's going to say if you got the name wrong, something like that. Now let's imagine you got your program wrong. I'm sure you would never do that because you're an expert programmer. But some of us are amateurs and we might write our program wrong. So instead of typing print, let's imagine you type print123 instead. And then if I do save to save that program and run it again, let me move that up so you can see. Press return, what does it say? Well, it says invalid syntax. Basically, there's something wrong in your program. So those are the kinds of messages you might see. If you see any of those messages, just check back over the instructions, check out the blog post on artificialworlds.net/blog, and hopefully, once you've corrected it so that it looks exactly as I've shown you, then it will act in exactly the way I've shown you. That's it for today. We've written a program, we've run it, and it works. Next time we're going to write a program that actually looks something like the game we want to write, and I'll explain exactly what that game is. So, see you next time. Hi, my name's Andy. This is the third part of our series about how to write your first ever computer program. A game, a very, very simple game for your Raspberry Pi. And by the way, this will work perfectly well on another computer, and if you do it on a Linux computer, doing it will be pretty similar to what we're doing on the Pi. Check out the blog post for any of the details if you miss them as they shoot past. But today we're going to do we're going to find out what the program we're writing actually does, what the game's going to be like, and we're going to write the complete outline of that game. at the end of this, we're going to have written the whole program, but none of it's going to work. It won't even run correctly. Sounds exciting, right? So let's have a look at our Raspberry Pi. Remember from last time we got to a great big Raspberry and we learned how to open up the text editor and then run the program in a terminal. So let's open up that again. So let's open LeafPad. I've kept the fonts quite big in LeafPad as we had them last time, just so you can see what's going on. So the first thing we're going to do is load up the file that we made before, and we're going to completely delete everything in it. So File, Open, click on Pi, and then choose redgreen.py, which is the program we wrote last time, which just said hello to us. We're going to completely delete all of that, and we're going to write a new program. And I'm going to try and convince you through this series that writing computer programs is a bit like casting magic spells. One of the best ways of writing a program is to just assume that the stuff you're not thinking about now is magic, and then think about it later, or perhaps you've already thought about it. But particularly if you do it and then if you write it as if it already exists and then think about how to do details later, you often end up with quite well-structured programs that make sense at each level, because you don't think too much about the lower levels while you're writing the higher level. If you want to know more about that, there's this amazing book called The Structure and Interpretation of Computer Programs. Don't read it yet, but when you read it, you're going to love it. Okay, so let's write our program. And our program is going to consist of... well, let me explain what it does. So we're going to write a game. It's going to be an extremely simple game, which tests your reactions. What's going to happen is, the screen will be blank, where it's saying ready, and then a green circle will appear, or a red square will appear. If the green circle appears, you have to quickly press a key. If the red square appears, you must not press a key, or you lose points. It'll do that a few times, and that will be the end. So, a very simple version of that program, or the very simple outline of that program, is going to go something like this. So we need to start off what we're doing. So I'm going to type the word start. So if you're following along, try and type exactly what I'm typing, same case, same type of bracket, everything like that. So we're going to have to start up. So we'll start. We'll put a bracket there. A bracket means that you're doing something. So in Python, you can write a thing which is a sort of a mini program called a function, and you give it a name. So we're assuming that there's going to be a function called start. And then to call that function, you put that bracket there. Later on, we might have some things in between the brackets, which is stuff that you're passing into that function, that sort of mini program. But for the moment, we're just going to say you start. Just do it. So start. I'm going to have another one called ready screen. So basically, say to the person who's playing this game, get ready. There's going to be a shape coming. Then we're going to wait. So we show the ready screen and then we wait, and we wait for a slightly random amount of time so that they don't know exactly when this shape's going to come. So after the wait, we're going to show the shape. So I'm going to call a function not yet written called shape. And then finally, once we've finished, we want to tell the person how well they did and so on like that. So we're going to pretend that there's a function called end. So this is purely pretend at the moment. This is our whole program. Start, display the ready screen, wait for a period of time, show a shape to the person and find out whether or not they press the button, and then show them a screen at the end saying well done or not well done. Okay, so we've finished, right? Well, let's run it. Open up the terminal just like we did last time. Oh gosh, that's big. Let's make it a bit smaller, shall we? I wonder why it's so big. I think it has a standard size. And I've made the font big, so it has a standard size in characters. Okay, so our program is in this directory because we put it inside the Pi. So to run it, we can just say Python redgreen.py. And what is it saying to us? Well, it doesn't look good, does it? Something's gone wrong. It's not showing us any green shapes, that's for sure. What it says is, look at the last line, that's of interest to us. It says name error. Name start is not defined. So if we look back at our program, the first thing our program does is it calls a function. It tries to run this mini program. The mini program it's trying to run is one called start, but we haven't actually written anything called start yet, so it doesn't actually work. And that's where we're going to leave it. We've written our magic spell. We don't know how it's going to do it, but we know it's going to look something like that. And next time we will start looking at how each of these ingredients, how each of these functions that we're pretending exists, might actually be written. We'll probably write 1.5 of them next time. So see you then. Hi, my name's Andy, and this is part 4 of my first Raspberry Pi game. Series of videos where we are going to create your first ever computer program. It's going to be a really simple game, and it's going to be running on your brand new Raspberry Pi. So this week we're going to try and make an actual window appear, which is going to be completely black. So last time, you may remember, we wrote what I was describing as a magic spell. We wrote down this incantation, a list of things that were going to happen, but we hadn't actually written the ingredients, the details of what happens in each of those sections that we've made. So just want to encourage you, have a look at the blog that you can see up there. I can't do that, it's really bad. It's got all the details. It tries to explain it in detail, especially if you're a kind of ready kind of a person. Read it. It's also got a link to the full version of the game here where my mouse is, the version that you should end up with at the end of this video. Okay, so we've got a program which calls some functions which don't exist yet, and it doesn't work. We saw at the end of last week that it just didn't work, and the reason it didn't work is because it didn't know what start was. So there I'm highlighting start. So the first thing we're going to do is we're going to make start. So what we're doing on this line is we're calling a function called start, or we're saying run this function, which is called start. A function is like a mini program. So we're telling it to run start, but we haven't actually written start. So let's write it now. And the way you write a function is like this: def, def, and the name of the function, which is in this case is start, and then bracket, same kinds of bracket as before, normal brackets. Then a colon, and that's the bit at the beginning which tells us this is going to be a function. And then we press return, and then we type, and you have to be really careful about this, we type 4 spaces. 1, 2, 3, 4. And then at the moment, I don't want this function to do anything. I just want to know it's there. I don't want it to do anything. So I'm just going to type pass, which means do absolutely nothing. And now we've finished our start function. We've got a few more functions that we need as well, so let's write them as well. So let's write ready screen. Whoops. Again, 4 spaces. And then wait. Another 4 spaces. And then the next function we had was shape. And the last function we called end. So each of these functions consists of a line telling you the name of the function, telling you that it exists, and that always has def. Def just stands for define. It means define a function. And then the rest of the function is any lines that come after that which have 4 spaces at the beginning. In Python you can use the tab character or any number of spaces, but let's just not do that. Let's just do 4 spaces, and no one will get confused, because it can get really confusing, especially if you mix up tabs and spaces. Things go badly wrong. So for the moment, just always type your 4 spaces. It might seem annoying, it's not actually. You'll get used to it really quickly. Okay, so I've done that. So I'm gonna, what I forgot to show you on the last video was I was pressing Control S to save, but what I should have been doing to show you is clicking on the save button. So go to the file menu and click save. And then we're going to go over to LX terminal. So this program, by the way, is LeafPad, exactly as you saw it before. Let's go over to LX terminal, which I've started up exactly as we started it before, and let's run the program. We run the program the same way as before. We type Python redgreen.py, and then we press return. And this time, instead of getting an error like we got last time, absolutely nothing happens. So that's progress. Believe me, that is progress. It may not seem particularly exciting, but we'll get there. Okay, so now we've got a working program that does nothing. So we're going to make it make a black screen. The first thing we need to do is go to the very top and type this: import Pygame. And what that means is we want to start using this code that someone else has written, which is called Pygame, which is a set of pieces of code which help you write games in Python. So the Pi is for Python, the game is for writing games. There's a website for Pygame, you can find all about it, but for the moment all we need to know is, once I've written import Pygame like that, then there is something in my world now called Pygame which I can use. Next thing I want to do is immediately below that I want to make a variable, and I'll explain what that is. So screen size, notice again I'm using underscore. This character is near the 0, it's above the dash, so if you press shift dash, at least on my keyboard, you get an underscore. The names of things can't have spaces in them, so if we want something that looks like a space, we use an underscore instead. So screen size equals 640, 480. So what this line does, any line which has the name of something and then equals and then some other stuff, is making or modifying a variable. So in this case we're making a variable called screen size. A variable is just a thing with a name which holds onto something for us. So we're making this variable called screen size, and what we want it to hold onto is this list of numbers, these two numbers, 640, 480. The reason we want to hold onto those numbers is because that's the size of window that we want to use. We want to make a window which is 640 pixels across and 480 pixels down. And we haven't made the window by writing this line. All we've done is remember those numbers in this variable called screen size. So variables are a very important thing to learn when you're programming. You'll use them a lot. Okay, so now we're going to make our start function actually put a window on the screen. And the way we do that is we get rid of this pass. The pass was just there to say this is a function, but there's nothing in it. Pass just means do nothing. So instead of pass, I'm going to delete that. I'm going to type this: pygame.init bracket. So we're using this Pygame thing which I said we'd got hold of earlier. We got hold of it using this import statement up here. Now we're using it, and what we're doing is we're saying this dot means look inside the object. So Pygame, look inside Pygame, find the thing called init. Init is a function, just like this function that we're defining here. This function is defined by the people who wrote Pygame. We don't have to worry about how to write it. We can just call it. So we call it. It's called init, and basically any program you write, any game that you write which uses Pygame, you need to have a pygame.init at the beginning or something similar. Okay, 4 spaces. Notice that the next line is exactly the same number of spaces as the line above. We call that indenting, so it's indented by the same amount. It has to be, otherwise Python won't know we're still writing the function. It'll think we've gone off and done something else. So the next line is this: screen equals, so notice we're defining a variable here. We're given the variable name and then an equals to say there's going to be a variable called screen, and the screen that we're going to create we're going to get out of Pygame again. So Pygame.display.set_mode. See if I can make this window a bit bigger. I might have to make my font smaller at some point as our program gets longer. So what we're doing is we're saying look inside Pygame for something called display. Look inside display for something called setMode. SetMode is a function, and we're going to put this in between the brackets for the function. So you haven't seen this before. Let's make our font a bit smaller. Whoops. Whoops. Typing fail. Okay. Let's see if we can fit it all on. Okay, so we're going to say setMode, and then instead of just having bracket like we had before, we've got a bracket and then something in between the brackets and then a closed bracket. So this is called passing an argument to a function. What that means is passing some information that the function needs to do its job. So the setMode function takes in an argument which is the size of the screen that we're going to create. So setMode creates a screen, and it takes in the size. So we're giving it this size, which is just 640, 480, 2 numbers. And then the answer to all of this stuff, when we finished calling it, is going to get put into this variable. So screen is going to hold on to the screen that got created. Okay, if any of this doesn't make sense, do add a comment or something, do something social networky, we should be okay. Okay, so where have we got to now? So that will actually create a window on the screen, but it will, then the program will just carry on and we'll get to the end of the program, and stop, and then the window will go away immediately. So we haven't quite got there. What we also need to do is make the program wait for a bit after it's made a window. So let's do that. So here's how we're going to do it. Pygame. So we're going down to the end. Sorry, I should have said going down to the end function, because at the end we want to wait. So pygame dot event dot clear. So we're looking inside pygame for something called event, and then inside event we're looking for something called clear, and that thing called clear is a function, so we're calling it, not passing any arguments this time. And then there's another line to this function as well. 1, 2, 3, 4. Pygame.event.wait. So these are two functions that are part of Pygame. I need to explain what they do. The first one says if anything has happened, if the user has pressed any keys or anything like that earlier while we were using the program, throw away that information. So clear just means we don't care what happened before. Then the next line means wait for something to happen. So wait for the user to press a key. The person playing the game, I mean. Now, when I say the user, I mean the person playing the game. So they might press a key, they might click something on the mouse, or in fact, they might even just move the mouse in front of the window, and that will be enough for this wait to stop, and then we'll get to the end of the program and the window will close. So in a minute we're going to run this, but when you do run it, be careful not to move the mouse, or it will immediately close, because this wait function will stop waiting when you move the mouse. So save our program, redgreen.py, go back to LX terminal, and we're going to run it. Python redgreen.py, press return, and don't touch the mouse or the keyboard or anything. And you can see, by the magic of television, a black window has appeared. It says Pygame window at the top because we haven't given it a name, so that's the name it gets. And as soon as we touch anything, press a key or move the mouse, that window will disappear. So let's move the mouse just to demonstrate how fragile that is. I move the mouse and off it goes. So if this doesn't appear to do anything, definitely check whether you're moving the mouse. That might be causing it to immediately disappear. Okay, check out the blog post which is linked in the show notes. If you need to check any of the typing, feel free to pause the video, watch it over and over. Next time, if you're really lucky, we're going to put something on the window, so it won't just be a black window, it might even have some writing on it. See you then. Hi, my name's Andy, and this is part 5 of my first Raspberry Pi game, where we're going to write your first ever computer program on your Raspberry Pi. The computer program is a really simple little game that is going to display a green thing, and if you have to quickly press a button if you see a green thing, not press a button if you see a red thing. Last time, which was part 4, we made a blank screen appear, and a window pop up with a blank screen in it. Nothing else. This time we're going to put some actual writing on the screen. You are going to be impressed. Check out the blog post. Here's my magic pointing. It's got loads of information there, hopefully easier to consume if you get lost. And it also has a link to what your redgreen.py file should look like at the end of this lesson, this part. So check that out. So let's get back to our Raspberry Pi, see how it's looking. So we've got LeafPad open, we've got LX Terminal open at the bottom there. So this is how our program looked at the end of last time. We made a screen, so we opened up a window, and then we added this code to wait. So we've got an empty screen, and then we wait until something happens. And even someone moving the mouse is enough to make it stop. We'll fix that sometime, but not yet. And this time we're going to put some writing on the screen, but just before we do that, I'm going to show you a couple of tricks that just make our life slightly easier. So first thing, go to the very top of the file. Very top. Don't leave a blank line first, it has to be the absolute first line of the file, and type this. Hash, or pound if you're an American, and then exclamation mark or exclamation point if you're an American, and then type this /USR/env, sorry, USR/bin/env space Python. So what we're doing here is we're telling our Raspberry Pi that this program is a Python program. So instead of having to run it by typing Python and then its name, once we've finished with our tricks, we'll be able to run it directly, and the Raspberry Pi will just know it's a Python program. So the first thing is this line, which just says run this program using Python. Save it. File save. I just press Control S. I do that compulsively. Okay, so once you've saved it, go to LX Terminal, and then what we're going to do is tell your Raspberry Pi that it's allowed to run this program directly instead of just passing it to another program, which is the Python program. So what we type is this: chmod, chmod, and then a plus, well, a space, and then a plus, and then an X, and then the name of the program, which is redgreen.py. So chmod plus X, redgreen.py, press return. If all went well, absolutely nothing will happen, which is the way of things on Linux and Unixes. And now, if we want to run our program, we can do it a different way. Instead of typing python redgreen.py like we were before, we can just type /, which means look in this directory. / just means this directory, and then the name of the program, redgreen.py, and press return. You have to wait a little while because the Pi is not the fastest thing, and you'll see that our program's run. It's popped up our blank window. So press a key to make it go away. And there it goes. So no longer do we have to type python redgreen.py. We can type the shorter and more meaningful / redgreen.py, which means run our program, and it knows that our program is a Python program. It sorts it all out for us. Just a little trick. Nothing to it. We didn't need to do it. Just we've got to do it sometime. It's fun. Okay, so let's start off with the real work to make some writing appear on the screen. The first thing we need to do is we need to look at this line with the screen size. Before we were happy with just the screen size just being a list of 2 numbers, and we didn't need the numbers individually. Now I want the numbers individually. I'm going to split this up a little bit. So I'm going to type this: screen width, screen underscore width equals 640, screen underscore height equals 480. And then instead of repeating this information again, which would be a waste and might cause mistakes, I'm going to make the screen size by building it up out of screen width and screen height. So screen size is a list of the width and the height, but now we've made new variables called screen width and screen height, which hold on to the width and the height separately because we're going to need them later. And I've made screen size out of those variables. Just as a reminder, a variable sounds clever, but actually it's just a thing with a name that holds on to something. Okay, so we've made screen size out of those 2 other variables now. The next thing we need to do, because we're going to use them later, is make 2 more variables but put absolutely nothing in them. So this is how that's going to work. Screen equals none. None is a special word in Python, which means there's nothing at all there, but there will be at some point, presumably. I'm going to make another one called ready text. So this is the writing. You're getting the idea? And again, ready text is going to be equal to none, which means make this variable but don't put anything in it, or put none in it, put nothing in it. So we've made those variables. Now let's go and look at our start function. We're going to add a bit of stuff to it. What we're going to do is we're going to tell the start function about those variables we've just made. So let's type it and I'll explain. We use the word global, and then we type the names of the 2 variables we've just made, ready text and screen, with a comma in between them. What this is doing is telling the start function, when you're dealing with something called screen and something called ready text, don't deal with it just inside your function, inside you, the start function, but deal with the ones that we know about from the outside. So global means it's visible everywhere. Those 2 things, screen and ready text, I want you to use the ones that are outside of you, not just ones that are inside. If we hadn't put global there, we might end up dealing with something called screen or ready text, which is not actually the same thing as those things we made at the top. They just happen to have the same name. So you'll notice a few lines down we set screen to be to be the window that we're working with. We want to make sure that the screen that we set there is the same screen that we made outside, because we're going to use it in other places. So global just means make it the same as the one from the outside. Okay, so once we've done that, we're going to do a couple more things. The first thing is we're going to make a font. So remember 1, 2, 3, 4 spaces to get to the same place, so that we know that this line is the part of the same function, this start function. We're going to make a font. A font is a way of writing. We're going to call our font, and we're going to make it like this. Pygame.font. F font means make a new object, which is a type of, which is a font. And then we're going to type none, and then screen height, which is the variable we defined up above, divided by 5. So let me explain this a little bit. So this stuff means look inside Pygame. Dot means look inside. Find something called font. Look inside that and find something called F font, which we call. And you can think of this thing as a function. Actually, it's a thing that makes an object called a font. So we're going to make a font, and the way we're going to make it is we're going to pass in none, which means we don't care what font it is. It could be Arial, it could be Verdana, it could be Times New Roman. For the moment, we don't care. So we just say none for I don't care. Just pass in nothing there. And then the next argument, so here there are 2 arguments to this function, 2 pieces of information being passed into this this font. Not really a function, but let's call it a function for now. And the second argument is the screen height variable that we created up higher up. But we're doing a sum on that screen height. Instead of just passing in the screen height as it is, we're doing a divided by. So this is a / and then a 5, and that means divided by 5. We don't use the divide sign or anything like that. This is supposed to look a bit like a fraction. You've got screen height on top and 5 underneath, so screen height divided by 5. Lots of programming languages have a / like that to mean divide. It's a bit weird if you're used to writing a division sign, but I haven't got a division sign on my keyboard. It's a lot easier to use a /. In fact, division sign won't work, so don't try. Okay, so type 4 spaces for our next line. So we've made a font, which we're going to use to make some writing. So here's where we make some writing. This variable, ready text, which we've created higher up and we've said is global, so that what we're doing here is modifying something that is going to leak out of this function into the rest of the program. So ready text equals, so we're changing what this variable is pointing at. Font, which is the object we've just made, this font object, and we're calling a function on font called render. And what we're asking it to render is the word ready. We're passing in a 1, which you can ignore. And then we're going to give it a color. Let's make our font smaller yet again, so that we can see what we're doing here. Is that going to do it? Let's see whether that does it. So the color we want is white. Let's get rid of some spaces, right? You should always have loads of spaces in your code, but let's get rid of a couple just so we can fit it on. So we're modifying the variable ready text by saying ready text equals something, and the thing that we're saying it should be equal to is the answer that comes back when we call this function render on the font object. So render means draw into a picture. So we're saying take this writing. The writing that we're passing in is this thing between quotes, just like in the Hello World program we wrote, where we put a string of characters in quotes to say hello world. Here we put a string of characters in quotes saying ready, and then something else which you don't have to care about, and then the color that we want you to draw it. So the color we want is white, please. So make an image, put it inside ready text, and that image should be the word ready written in white. Easy, right? Okay, so what do we do next? Well, now that we've got this image, this picture, which is the word ready written in white, we can draw it on the screen. And the way we do that is we modify the ready screen function, which is where all the magic's going to happen. So we're going to do it like this. We're going to make another variable inside ready screen. Remember, this function gets called further down. Let me scroll down and just show you. Remember, all these functions don't actually run until we get to here. So we say start, which is the bit we've just been doing, and then we say ready screen. So that's where we get to. That's how we get to here. So we're going to run this ready screen function. We're going to make a variable with text pos, and we're going to set it to be ready text dot get rect, and then an open bracket. So we're making a variable called text pos. The way we make it is we look inside the thing ready text that we made up above for a function called getrect, and this text pos is going to store where on the screen we want to draw our piece of writing. So getrect, that's not the end. We've got a lot more to write, but we can't fit it all onto this line. There's too much. So what I've done is I've put a bracket and I haven't closed it yet. And Python knows if you've put a bracket and you haven't closed it yet, you haven't finished with this line. You might be starting onto another line physically in the text editor, like I am here. 1, 2, 3, 4. 1, 2, 3, 4. We might be moving on to another line in the text editor, but as far as Python's concerned, this is all one thing. It's like one sentence in a piece of English. So all of this line is just about making this text pos thing, which is going to be where the text appears on the screen. But it's a complicated line, so I've broken it into separate lines. The reason Python is okay with that is because we've got this bracket which hasn't closed yet, so Python knows you haven't finished yet. So we're going to type this: center x equals screen.getWidth divided by 2, and then a comma, and another line just the same level of indentation. Center y equals screen.get height divided by 2 with no comma. Finally, 1, 2, 3, 4. We're going to finish off the line by closing the bracket. So we're calling the getrect function, and the end of the getrect function call is on this line, fourth down. In between, we've got two arguments being passed, two pieces of information being passed to the getrect function. One is this lot, and one is this lot, and there's a comma in between them. It's all on separate lines, but you can think of it as all one thing. So the other thing to notice about this this code we've written is instead of just passing in this sum, which incidentally is halfway across the screen, it's the width of the screen divided by 2, and the height of the screen divided by 2. So these two numbers are going to be the amount of pixels it costs you to get halfway across the screen, the amount of pixels it takes you to get halfway down the screen. But notice, instead of just passing them into getrect, what we've done is we've given them names. So inside this function call, we've got something that looks like we're making a variable, but we're not. What we're doing is saying the argument that we're passing, the piece of information we're passing, is center x, and the next piece of information we're passing is center y. So we're telling the getrect function which arguments we're passing. The reason we're doing this is getrect can take all kinds of different arguments. And we're passing these two, but we could have passed all kinds of other things. So it needs to be told which arguments we're passing, whereas with the functions we've seen before, like set mode, it's clear to set mode that this argument is the screen size. There's not loads and loads of other arguments it could be. In the case of getrect can take all kinds of different arguments. So we're telling it we want the center of our text to be halfway across the screen in the x direction, and the center of our text in the y direction we want to be halfway down the screen. So now inside text pos we've actually got a rectangle, or the locations of the corners of a rectangle, which tells Pygame where to draw something. We haven't actually drawn it, we're going to do that now. Here's how we draw it. 1, 2, 3, 4. So notice, by the way, we can have a blank line, and that doesn't mean we leave the function. So we're still inside this function called ready screen, because the line here still has 4 spaces in it, and the only lines in between were empty. If we'd made a line in between here, if we'd made a line here saying print hello, let's just do it. That would mean we'd got to the end of ready screen, and then this line wouldn't make any sense. How can you carry on with ready screen when you've already finished it? So we're not doing that. We're carrying on with ready screen. So just to make the point again, the way Python knows whether you're inside a function or you've finished it is the number of spaces at the beginning or the number of tabs at the beginning. So you have to be really, really careful that all the lines that are in this function start with these 4 spaces like this. Text pause, and here 4 spaces at the beginning. So here's how we write something onto the screen. We say screen.blit. Then we say what image you want to draw on the screen. So in this case, the image you want to draw is this thing called ready text. And then where do you want to draw it, which is this variable we've just made called textpos. So the name blit comes from the dawn of computing history. It means draw an image. Why it's called blit is lost in the mists of time. There's a link in the blog if you're interested in finding out about it. So now we've done it, we've drawn our writing on the screen. But the last thing we need to do is tell Pygame, I've finished with all my drawing. Now show the drawing that I've been doing. So how we do that is this: pygame.display.flip. So flip is a reference to the fact that actually there are 2 screens behind the scenes. There's the screen we're drawing on and the screen that we're looking at. And when you say flip, it takes the screen that you're drawing on and makes it the screen you're looking at. So you can draw quite happily as much as you want, and you won't see it until you say flip. And suddenly Pygame will show everything you've been doing. It's quite useful for if you've got lots of complicated drawing to do. We've done a very simple bit of drawing, which is just writing a bit of text. Okay, all kinds of waffling, but I believe we have finished. So save it, file, save. Go to LX terminal and type /redgreen.py. Are you ready? Is this going to work? Look at that! We've got a black screen with white writing on it saying ready, and we can make that go away by moving the mouse, clicking the mouse, or pressing a key. Let's do it. So if you got that far, well done. You've done your first bit of graphics programming. And next time, I think we'll be looking at how to get something. No, we won't. Before that, next time we'll be learning some of the most interesting and difficult concepts in programming to make the window not disappear when you move the mouse, only disappear when you click something or press a key. So see you next time. Hi, my name's Andy. This is part 6 of my first Raspberry Pi game, where we make a really simple game on our Raspberry Pi. Today we're going to do something really dull that has to be done. But fortunately, we are going to cover, as part of that, 2 of the most important things you need to learn when you do programming. So you're not going to find it dull, you're going to find it eye-opening. So you may well want to have a look at the blog post that will be linked from the show notes. It's got all the details here, all of the code, and it also has a link to my version of redgreen.py. Just in case yours doesn't work, you can compare it against mine and find out what we did differently. So let's jump into the Pi and get on with it. So open up LeafPad just like we did before, and open up our program, which looks like this now. And also while you're there, open up LX terminal, just put it behind there, we'll use it later. Okay, so we've got our program, and it displays a black screen with the word ready on it. What's going to happen at some point is that after the word ready's appeared, a green circle is going to appear and you have to press a key quickly, or a red square is going to appear and you have to not press a key. That's the game. But for now, we're not going to get any further with any of that stuff. What we're going to do is get rid of a problem that we've got in our program at the moment. So the problem is that ready screen disappears when we move the mouse. What we want is for that ready screen only to disappear if you click the mouse or press a key. If you just move the mouse around, we want it to stay there. So it's a really simple thing we want, but we're going to cover some really cool, meaty programming topics to be able to do it. So what we're going to do to start off with, because we're going to need it, we're going to add a new line near the top here. We're going to write import sys. So sys, things like Pygame and sys, they're called modules. They're basically files that we've got somewhere on our system which contain some code. We need some code inside sys, so we're going to import it at the top there. And then we're going to go down, and the first thing we're going to do before we do the real hard work is we're going to make a little function. We're going to put it just above ready screen. We're going to call it quit. So this is the way we define a function. We say def, which means define, then we give the name of the function, which is quit, and then we put bracket, and then we put a colon saying I'm about to start the function. So press return, and then I do 4 spaces as normal. 1, 2, 3, 4, and then I put the stuff that lives inside this function. Function's like a mini program. So this function is going to contain this pygame.quit and 1, 2, 3, 4 sys.exit. That's where we're using sys. You know, we imported sys a minute ago. That's why, because we're going to use it there. So what we've done is we've made a function which we can call. We're not calling it from anywhere yet, but we can call it. When we do call it, we will stop everything. We'll quit from the game. And the way we do that is we tell Pygame we want to stop everything. So Pygame.quit tells Pygame turn everything off that you had turned on. That stuff all mostly got turned on when you did Pygame.init up here. That tells Pygame to get started with some stuff. Pygame.quit says alright, stop all that stuff. And then sys.exit is a part of Python itself, which says completely stop everything you're doing. So when we call this quit function, that's it. Nothing else is going to happen after that sys.exit. Anyway, we haven't called it yet. That was just something we know we're going to need. So now let's go down to the real business end. What we're going to do is we're going to have a look at the end function, which is we've already got here, and we're going to fix this problem with it. The problem we've got is that this is fine. This clear line is fine. That says don't worry about any events that happened before, anything the user pressed or anything like that, the person playing the game. If they pressed anything or moved the mouse before, just ignore it, forget about it. And then the next line says, if they do anything, well, it says wait until they do anything. As soon as they do anything, stop waiting. But we don't want that. We want to wait until they do something interesting. And it turns out we're going to need to do quite a lot of work to get that interesting in there. So let's get rid of what we've got there. That's no good. 4 spaces because we're still part of the end function. You have to indent all your code in Python so that Python knows we're still in the function. If we wrote a line that wasn't indented, it would think it was outside of the function, that you'd finished doing the function. We want to write another line of the end function, so we have to do that on 4 spaces to make sure Python knows we're still inside the function. The first thing we're going to do is we're going to make a variable called event underscore types underscore that underscore cancel. So I'm sorry, that's a long name. I couldn't think of a way of expressing what I wanted to express in a shorter name. And the events that we care about are something called a key down event. That's when the user, the person playing the game, presses a key down. And the other one is mouse button down. I'm going to let that scroll off the end. So all that happened there was the windows got slightly wider. Don't worry about it. We know it says mouse button down over there. So what we're saying is we're making a variable called event types that cancel, and it's a list of events that we care about. And the events that we care about, the things that could have happened that we care about, are key down events and mouse button down events. Okay, so that's just a list. Doesn't do anything, it's just a list. Okay, now we need another variable. We're going to call it waiting. And we're going to set it to this special value, which is called true. Which means true. It means yes, we are waiting. Well, yes, it means sort of yes to whatever, but we're using it to mean yes, we are waiting. And now, if you're wondering where the meat was coming, because you've seen variables before, here's the meat. So, we're going to write this, while waiting, colon. And what this says is, we want to make a thing called a loop. And the type of loop we're making is a while loop. So what's a loop? Well, a loop is a bit of code that runs multiple times, over and over and over again. And a while loop is a loop that runs multiple times forever until the second part becomes false. So you'll notice from the line above, waiting is currently true,
And we will keep on repeating the stuff in the loop until waiting becomes false. Well, you are probably asking, what's in the loop? What is this while? So the while says we're starting a loop, and we're about to do the stuff that's in the loop. So let's do it now. So 1, 2, 3, 4 to get level with while, and then everything that goes inside the loop you need to indent again. So 1, 2, 3, 4. So what we're telling Python is this line is inside of this loop. That means this line is going to get run repeatedly. It's going to carry on running and running and running until waiting is no longer true. And we'll see how waiting changes in a minute. So the first thing is we're going to make a variable called EVT, which just means event. I could have called it event, but there's a load of things called event, so I called it EVT. And what we're going to do is call the function that we saw before, that wait function. So what we're saying is wait for something to happen, but this time don't just stop when it happens, but pass the thing that happened back and put it in this variable. So EVT is going to be the thing that happened. So 1, 2, 3, 4, 1, 2, 3, 4, another line in the loop. So the first thing that we do every time we go around the loop is we say wait until something happens, and when it happens put what happened into EVT. It's an event. Now we're going to learn about our second meaty topic, one of the most important things in programming. You might call it conditional execution, but I would call it if. So we're going to write if, and we're going to ask something about this EVT thing. So what we're going to ask is what its type is, and if its type is this special type, pygame.quit. So let's go through the bits here. So we're saying look inside EVT for this thing called type, find its type, find out what type of thing happened. So EVT is the thing that happened, EVT.type is the type of thing that happened. And then we're going to ask a question. The question we're asking is it equal to something else? So that equal is not the same as the single equal that we saw above, where we're making a variable, changing or creating a variable. Here we're asking a question. Is it the same thing as something else? Is it equal to something else? So if the type of the event is, so that equal bit in the middle means is, pygame.quit. And pygame.quit is a special type of event, which means, which is a quit event. And what that means is someone clicked the top right hand corner, the X in the top right hand corner, or they pressed Alt F4. They closed the window. So if the person using the game closes the window, then an event will happen. It will go into that EVT variable, and its type will be pygame.quit. And what that means is that this thing that we're giving to if to say if this is all true, then we're going to do something. Is going to come out. It's going to come out and say yes, that is true. Event.type is quit, but that's only going to say it is true if the person using the program closed the window. Otherwise, it's going to say no, that's not true. We won't do the next thing. So, what's the next thing? So 1, 2, 3, 4 to get level with while. 1, 2, 3, 4 to get level with if. And then we're going to do another 1, 2, 3, 4 to indent a little bit further. So all the lines that are indented after an if only happen if the if thing was true, if the condition was true. So in this case, this thing that we're about to type is only going to happen if this was a quit event, if the person closed the window. And what we're going to do, you might have guessed it, is we're going to call our new function called quit. So if the person asks to close the window, we're going to call the quit function, which will close the window for them. So they'll be happy about that. And that's all we're going to do. But if this wasn't a quit event, we're not going to do that. We're going to completely ignore this line that says quit. We're just going to skip straight over it. Okay, so let's see what happens next. 1, 2, 3, 4, 1, 2, 3, 4. So we're saying that we're no longer in the if, we're doing stuff that's going to happen whether or not we got into the if. And we're going to make another line, it's called elif event ebt.type in event types that cancel. And again, we're putting a colon. Notice that whenever you're going to indent some stuff, you put a colon there. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And what we're going to say is waiting equals false. So what we're saying is else if is what this means. So it means if we didn't get into the first bit, look at the second bit. And the second bit says if the type of this event, so this is the same as what we had above, if the type of the event is in this list is the list of things we care about. So the list of things we care about is if they pressed a key or if they pressed the mouse button. So what we're saying is if the type of event is in the list of events we care about, set waiting to false. So only if it's an event we care about, we change what waiting is from true to false. Otherwise we skip straight over this line, and where do we go to? Well, because this is a loop, if we get to the end, we go straight back to the beginning. And we check again, is waiting true or false? So if this was an event like a mouse event, then it's not a quit event, and it's not a key press event, so nothing happens at all. So we go straight back to here, waiting is still true, and what we do is we just wait again for another thing to happen. But if this event was a quit event, we quit, we've seen that. If this event was a key down or a mouse down event, we change what waiting is. And what that means is that when we get back to this line while waiting, we're going to exit the loop. We're going to stop waiting because waiting is not true anymore. And the while loop carries on until the thing on the right hand side is not true. And we've just set it to false. So we're going to exit out of this loop. And that is it for what we're going to do today. Now, if we're very, very lucky, so what I did there was I did file save just to make sure you're clear. If we're very lucky, I would have typed all this right. And it's going to work. So let's try it. So we're going to run our program by going to LX terminal and typing redgreen.py using the trick we did last time, and we're going to press return. Give it a while because the Pi is a little bit slow. And now what I'm going to do is I'm going to move the mouse around willy-nilly all over the window. All kinds of events are happening here. And yet we're not exiting. But if I click, it goes away. Let's try again, and let's do a key press this time. So move the mouse around, nothing happens, press a key, away it goes. And finally, we won't be able to see a difference, but there really is a difference. Let's try closing the window. So when we close the window, it should also go away, but it should go away because we're calling the quit function. And indeed, there it goes. So well done. You have mastered, in one lesson, taking only a few minutes, looping and conditional execution. So the while thing, that was a while loop, which is a type of loop. And the if and the elif, that was conditional execution. You can tell your friends, you know all about it. Next time, we're going to draw a genuine green circle. See you then.
Hi, my name's Andy. This is part 7 of my Raspberry Pi game, my first Raspberry Pi game. We're writing a really, really simple game. It's the first ever computer program you've written. You can do it on your Raspberry Pi. You can actually do it on any other computer, and any other Linux computer is going to be pretty similar to what we're doing here. Today we're finally going to draw the promised green circle, which I've been talking about for ages. Do check out the blog post you can see behind me. It's got all the information that I'm going to give you here, and it also has a full version of the code that you can compare with yours if something goes wrong. So we're back on the Raspberry Pi. I've got LeafPad open with our file open called redgreen.py. We're going to be changing it today so that by the end of this, instead of just popping up a ready screen which asks whether you're ready and then exits, we're going to pop up a ready screen and then a green circle. And the idea is eventually, when the game's working properly, when the green circle comes, you're supposed to press a key quickly, but if a red square comes, you're supposed to not press a key. So first thing, we're going to make this ready screen wait. Instead of waiting until you press a key, we're going to make it wait a certain amount of time. And the amount of time we're going to make it wait is going to be random. So we need to be able to use some random numbers. So we're going to import another module, and this module is called random. So import random. We'll just put that under import Pygame. I tend to put my imports in alphabetical order just to make my life easier. So what we're doing here is we're saying get hold of this module called random, which is a bit of code someone else wrote for us that we can use, and import it, make it available to us, and give it it's available to us under that name, random. Okay, so now we've got a function called wait. So if we look at the main structure of our program, which is right at the bottom, what we're planning to do is get everything started, then show a screen saying ready, then wait, then show a shape, and then finish. So what we're going to do first is we're going to make this wait function, which we've defined up here, but which is empty. It just says pass, which means do nothing. We're going to change that to do something useful. So what we're going to do is we're going to find out how long we want to wait, and then we're going to wait for it. So here we go. Time to wait. So we're defining a variable called time underscore to underscore wait, and we're going to use that random module that I imported at the beginning. And I'm going to call a function inside there called randint. I'm going to pass in two arguments, two pieces of information, and the two arguments I'm going to pass are 1500 and 3000. Notice there's no commas in the numbers here. That would confuse Python because it uses commas for something else. Okay, so what we're saying is get me a random number. An int is a number, integer. It's a mathematical term. So get me a random number, and I want it between 1500 and 3000. 1, 2, 3, 4. Indent your next line to be the same indentation level as your previous line because we're carrying on this function. So all we're doing there is making a variable which has a number in it. That number will be somewhere between 1500 and 3000. So now we need to tell it to wait, and the way we do that is we use a function that's inside Pygame, pygame.time.wait. And that function just takes in an argument which is how much time to wait. So we've made a variable called time to wait, and that's how long we want to wait for. The other thing I'm going to do is I'm going to add a comment to this line. So a comment is a little bit of writing which is completely ignored by Python, but which is useful for us when we come back to read this program. You should definitely pay attention to how easy or difficult it is to understand your program. When a human is reading it, it's actually more important than the computer, because if the computer misunderstands it, or the computer doesn't do what you thought it was going to do, it's going to be a human that changes it. So it's very, very important that a human understands your code. More important, it should be higher up in your mind than whether a computer can understand it. Okay, so what we're going to say is between 1.5 and 3 seconds. So it turns out these numbers over here are in milliseconds, because I consider that slightly confusing. I don't normally think in terms of 1500 milliseconds. I've added a comment which is telling any human that reads this that what we're asking for is a random time which is between 1.5 and 3 seconds. The way you make a comment is you type a hash, and then everything else on the rest of the line is ignored by Python. You can type anything you like there. And I also want a comment here next to this line. I'm going to say note, there's a bug in this, and the bug is that you can't close the window while we're waiting. So we're going to wait for this time, which is going to be between 1.5 and 3 seconds, and you can't close the window. We're going to fix that bug eventually, but for now we're going to put up with it, but we're going to put a comment there just so that we remember there's a bug in this function. Okay, so that's how we're going to wait. We're going to wait for somewhere between 1.5 and 3 seconds. Notice that this function here is inside time. So we've seen before something called pygame.event.wait. In fact, it's down here. What we're doing here is pygame.time.wait. It's a completely different function. Pygame.event.wait waits until an event happens. Pygame.time.wait waits for a certain amount of time. You can't interrupt it. Okay, so now we're going to wait for a random amount of time. The next thing we want to do is this function, shape. We want to draw a shape on the screen after we've finished waiting. So what we're going to do is we're going to make a new function first called green shape. So eventually we're going to be able to draw a red square or a green circle. So we're going to put our green circle into this separate function called green shape. 1, 2, 3, 4, and then inside that function we're going to actually draw the shape. We're finally going to do it. So let's make a variable called green, which is going to hold on to the color green for us. So the way we make a color in Pygame is we say pygame.color. Notice the American spelling.
and then we say which color we want, and Pygame knows about the color green. So if we give it this thing in quotes saying, I want the color whose name is green, Pygame knows about that and goes and gets it for us. Indent by 4 spaces to carry on this function, and we're going to make a new variable called center, which is going to point at the center of the screen. The way we get the center of the screen is we say screen.get width, and then we divide it by 2. That means we're halfway across the screen. Screen.get height divided by 2. So what we're saying is make a list of numbers, 2 numbers, one of which is half of the width of the screen, one of which is half of the height of the screen. And notice we've got brackets around the outside here. Quite often in Python we put brackets around lists like this. You don't have to do it, except when you do. In this case we don't have to do it, but where you need the brackets to group things, you need it. So before we've made a few lists by just putting things with commas in between them. That's fine, that's how you make lists in Python. Here we put brackets around them because quite often it makes it easier to see that this is a list. Okay, so we're going to make another variable called radius. The radius of a circle just means how far it is from the middle to the outside. So we're going to get a number which is about the right radius for our circle. And what we're going to do is we're going to use the width of the screen divided by 3 as a reasonable radius to use for our circle. So now we've got some numbers. We've got a color green and a list of numbers for the center and a number for the radius. Carry on this function, so we still type 4 spaces. First thing we're going to do is we're going to make the screen completely white. So screen.fill, which means fill the screen with color. Pygame.color white. So here we're making the color white immediately on this line as part of this. So we're doing 2 functions here. We're calling the function fill, and then the argument we're passing to fill is the result of calling this constructor which builds this color. A constructor is a way of making an object. What we're making here is an object of type color, and we're passing in white. So what we're saying is make a white color, and immediately once you've made it, that makes it. Once you've made it, pass it to this function fill, which says fill the screen with the color white. Then we're going to draw a circle like this. Pygame dot draw dot circle. It's a function called circle inside the draw, which draws a circle. And we're going to say where to draw it. Draw it on the screen. What color to draw it? Draw it green. Where its center is, which is this variable we made above. What its radius is. Then we're going to put a 0, which you shouldn't worry about for now. So we've drawn a circle. 1, 2, 3, 4. Finally, what do we do after we've done any drawing? We have to say pygame.display.flip, which says, now you've done all that drawing in the background, now I want you to display it. Bring it to the front and show me it. Okay, so that is all the code we need to draw a green circle. The last thing we need to do is change the shape function so that it calls it. So that is literally just this. So when we ask it to, when we run the shape function, which we saw below, we run as part of our main program, all it does is calls the green shape function. The green shape function draws a green shape. So if I've done everything right, I'm going to save it. I'm going to go to my LX terminal and I'm going to type ./redgreen.py, and hopefully we should see a ready screen and then a green circle. And indeed we do. And then the green circle is going to wait there until we press a key or something, because now we're in the end function that we wrote before. And the end function waits until you press a key or click a mouse. So let's click a mouse to get rid of it. And we've finished. Now let's try one more thing just to demonstrate the bug I talked about earlier. We're going to run this again. Oh, I'll show you a little trick. So this time I didn't type ./redgreen.py. On my keyboard I pressed the up arrow. And when you press the up arrow, you get to see all the commands you typed before. So I pressed the up arrow, I got back the command I typed last time. Now I can press return. Bit easier than typing it. Now let me close the window. Oops, I missed. Let's try again.
close this window. When it comes up, it won't close. So that's the bug I was talking about. The window doesn't close when the ready screen's there. If I close it now, it does close. So we'll be fixing that in due course, but not yet. Next time, we're going to find out whether or not you pressed the button, and hopefully even how quickly you pressed it. So see you then. Hi, my name's Andy, and this is part 8 of my first Raspberry Pi game, where we're trying to write a very simple game on our Raspberry Pi using Python and the Pygame library. Do have a look at the blog post, where we've got all the details, all the code, and a copy of the finished code in case you need it. So where we are at the moment is we've got some of our game starting to take shape. We're able to show a green circle on the screen, and the idea of the game is that when you see a green circle you should press a key. If you see a red circle you shouldn't press a key. At the moment we're only doing green circles, and it doesn't matter whether you press a key or not. But what we're going to do today is we're going to do the first kind of game-like element. We're going to we're going to wait and work out whether or not you pressed a key, and if you did press a key we're going to say well done, and if you didn't press a key we're going to say that was wrong. Yeah, so let's flip straight to the Raspberry Pi and just take a quick look at what our program does. I'm going to go as quick as I can today because there's lots to cover, but we'll see how far we get. So what our program does is it gets ready by doing this start function, draws the ready screen, waits for a random amount of time, about 1 or 2 seconds, and then it shows you a shape. And at the moment all it does then is it ends. What we want to do is make this showing you a shape thing a bit cleverer, so that it actually waits for you to press something and then finds out whether you did. So if we look at this shape function, what the shape function does at the moment is it just draws a green shape, because that's all we currently do. So if we go up and look at the green shape function, what we're going to do today is make the green shape function cleverer. So instead of just drawing a green shape, it's going to draw a green shape and then wait for you, and then tell you how well or badly you did. So let's go straight in there. We're going to make this green shape function longer. Remember, when you're adding something to a function, you always have to add the same number of spaces as you've got in the rest of the function. So we're doing 4 spaces for everything, so 4 spaces to add this line. And what we're going to do is we're going to say this. We're going to make a new variable called pressed, and that variable is going to be filled up with the answer that comes back from a function called shapeWait. So shapeWait means wait while there's a shape on the screen. We haven't written that yet. We'll write that in a minute. 4 spaces, and then now that pressed variable that we've just made has got the answer in. Did the person playing the game press a key or not? So what we can do is we can decide whether that was a good thing or not. So we know we've shown a green shape because we're in the green shape function. So pressing a key is good because it was green. So if they pressed a key, so we're writing an if statement. We're saying if pressed is true, that means if they did press a key, then 1, 2, 3, 4, and we're going to indent one more because we're going to say the then part which lives inside, which is indented further. 1, 2, 3, 4. So this is all the stuff that happens if indeed that pressed is true. The only thing we're going to do is we're going to call a function called green success, which we haven't written yet. But anyway, if they pressed a key, it's successful. So in a minute we'll write a function telling them they were successful. 1, 2, 3, 4, and then else. This means anything else. If anything else other than what we asked in the first question is true, then we'll do this other part. So we're always going to do one of these 2 parts. So 1, 2, 3, 4, 1, 2, 3, 4. If they didn't press a key, well then they failed, and we're going to print a message saying you failed. Okay, so we're finished, except we've got to write those functions. So the first function we're going to write is that shapeWait function. So we're going to go up above green shape. We're going to define a new function using def, which means define a function. The function we're going to define is called shapeWait. 1, 2, 3, 4. And the first thing we're going to do is something you haven't seen before. we're going to type in a description of what this function does. So what you're seeing here is two things at once. First of all, we're seeing the way Python lets you write strings of text that are longer than just one line. The easiest way to do that is to use this triple quote thing. What that means is start a string and don't stop it until you hit another triple quote like this. It's really useful in Python for all kinds of things you want to do where you want a long string which takes up multiple lines. But in particular, if we put a string like this at the beginning of a function, Python knows that is the documentation for this function. That is some information telling us what that function does, and Python can show that to people who are using our functions at useful times. Our other functions, most of them, the name is pretty much enough explanation. This time I felt like there was a little bit more that needed saying, so we've written that documentation string. If other people are using your functions, it's really good to have lots of documentation that explains what it does. Hopefully not just a copy of the name though. Okay, so now we're going to define a variable, and it's going to be a variable that looks quite familiar to you, and at some point we're going to fix it so we only write this stuff once, but for the moment we're going to write it again. So there's a variable called event types that cancel. So these are the events that might happen, the things the person playing the game might do that we're interested in. So they might press a key, or they might press mouse. And those are the two things we're interested in. Just checking my spelling. So we've seen something very similar, identical to that before. But yeah, for the moment, this function is doing something similar, but not the same as what we did before. So we'll type it again. At some point, we're going to have an episode where we just tidy up stuff and make it better, but not yet. So we're interested in those types of events. We also need to know how long we're going to wait, because this function is the function where we wait, showing a shape on the screen until either a key is pressed or we run out of time. So we need to know how long we're going to wait. So how long we're going to wait is 2000 milliseconds. We're adding a comment here. You may remember them from last time. Just some explanation that comes after a hash. Hash just means ignore the rest of this. It's useful for humans, but not for the computer. Okay, so wait. The wait time is 2 seconds. So now we're going to do something else. So I'm going to type this: finished waiting event ID equals pygame dot user event plus 1. Okay, this requires a bit of explanation. Basically, we're up until now we've only been dealing with events that happened, and then we responded to them. What we're going to do now is we're going to actually make an event and say and tell it to happen. And in order to do that, you have to say what type of event it is, which means we need an ID. So we're making an ID here. This is the ID of something I'm calling the finished waiting event. And in Pygame, just take it on trust from me. If you, whenever you're making your own event, you need an ID, and the ID that you should use is this pygame.user event value, and then +1 or +2 or anything bigger than that is fine. Don't make it smaller than that, because your ID, the type of your event, will clash with some events that are inside Pygame. Okay, so hopefully that made sense. 1, 2, 3, 4. I think I explained that better in the blog post, so if you're confused, try reading the blog post. Okay, so what we're doing is we're going to create an event. So we're asking the pygame.time for its function setTimer, and that setTimer function says to Pygame, please create an event for me that will happen at a certain point in the future. And the type of event we want is this finished waiting event ID, and the time when we want it to happen is in 2 seconds from now. So that's why we made that variable time to wait. There is a close bracket on the end there, it's just scrolling off the edge of the screen. Okay, so what we're saying to Pygame here is, in 2 seconds time I want you to make up an event, a made up event that I've made, instead of one of these events that's caused by someone moving the mouse or something like that. Okay, so we'll press straight on to the next bit. So now we're in a situation where we need to hang around and see what events happen. Either someone's going to press a key or click the mouse, or we're going to get this special event that we've made firing. So we know how to wait for an event. We've done this before, so we ought to be able to do this. And again, we're going to write code that's quite similar to what we did in lesson 6, and at some point we will combine them, but at the moment we're going to write them separately because they're slightly different, and hopefully it's easy to understand. So first thing we need to know is what's going to be the answer that this function sends back. So this function sends back an answer. If you remember, down here we asked shapeWait. We're expecting shapeWait to return an answer saying yes, you pressed a key, or no, you didn't press a key. So we need to send back an answer from shapeWait, and the way we do that is the very last line of shapeWait is going to be this. It's going to be the statement, the return statement, which says send back an answer, and the answer we're going to send back is something called pressed. But we haven't made pressed yet, so let's make pressed straight away. 1, 2, 3, 4. Pressed equals false. So far, the person playing the game has not pressed a key, and we're going to check whether they do in the meantime. 1, 2, 3, 4, and if they press a key, we'll change pressed to be true, and if they didn't, we'll leave it as false, and then the answer from this function, the return value of this function, will be false. Okay, so how do we wait for an event? Well, we do it the same way we did it last time. Waiting equals true. So we're making a variable called waiting. We're setting it to true, and then we're going to loop around, and we're going to have another while loop, and that while loop will only end when waiting becomes false. While waiting remains true, 1, 2, 3, 4, 1, 2, 3, 4. While waiting remains true, we're going to keep on repeating this next bit of code that I'm going to type. So this bit of code is again something you've seen before. First thing we do is we wait for an event by calling pygame.event.wait, which means wait for something to happen, and when it does happen, put the answer of what happened into this EVT variable. And then we have to just check what happened. So what we do is we ask what the type of event is. So if the type of event was a quit event because the person playing the game closed the window, then we quit. And we've written this quit function already, and that will exit straight away, so we don't have to worry about it anymore. That's completely finished. So other things that might happen. Else, if the event type is one of the things we're interested in, we made this event types that cancel variable. If it's something we're interested in, it will be in that list. If it's in that list, what we're going to do? Well, what we're going to do is we're going to say we are not waiting anymore because we've had an event that we're interested in, but also the event that happened was something particularly interesting. It was someone pressing a key. So that means we need to update the variable we've made called pressed to say yes, that's true. They did press a key, so the answer we return back is going to be true, which means yes, they pressed a key. Remember, it started off as false up here. So if they press a key, we set it to true, and then we send it back as the answer there. Okay, other things that could happen. If the type of this event is this new type of event that we made, called the finished waiting event ID. So what this line is saying is, if the event that we've received is the event that we asked Pygame to make, the one that happens after 2 seconds, then we finish waiting. So it bubbles up just the same way as these other events, which is quite useful. So what we're going to do in this case is we're just going to say, right, we finished waiting, so we set waiting to false, and what that means is when we get back to this line, because we loop round and round and round this bit over and over until waiting is false, but because we received this event, which means we finished waiting, we set waiting to false, we drop out of the loop and we carry on with the rest of the function. We get to this line, return pressed, and we send back the answer, which in this case is going to be false because they didn't press a key, so we didn't set pressed to true, we left pressed as false, but we came out of the loop because we set waiting to false, because we ran out of time. So when you run out of time, we return false. When you press a key, we return true because of this line which sets pressed to true. I hope that makes sense. Okay, so we're nearly there. One last thing we need to do before we exit is, if that event that we asked Pygame to make hasn't happened yet, then we don't want it to happen now because we're done with it. So we don't want it to happen later and confuse us. So what we're going to do is we're going to call this set timer function again. So it's the same function as we had up here, but this time the time to wait we're going to pass in is 0. What Pygame happens to know that if you say call set timer with a 0 as the time to wait, it will just cancel that event and get rid of it completely. Okay, so we've finished the shape wait function, which is the hardest bit of today's part. We have got more work to do though. Remember, there are 2 more functions we defined, sorry, 2 more functions we called that we haven't yet defined. Those were green success and green failure. Okay, so let's write them now. These are quite short, but then they use functions that we're going to need to write as well. So green success means, well done, you did press a key when it was green, which is what you're supposed to do. So we define a function. What that function does is it shows a green tick on the screen, which we're going to do inside a function called tick. And then it just waits. And annoyingly, again, it's going to wait in a way that means you can't quit or skip out of it at all. Which I don't like, but we're just going to have to put up with it for now, because the fix for that is going to involve fiddling about, mixing some code around. So all we do is we show a tick and we leave it there for 2 seconds, and that's it. That's all we're going to do. So let's do green failure. Same thing. Not the same thing, almost the same thing. So if you failed because you didn't press a key when you should have done when there was a green dot, we're going to draw a cross on the screen saying no, bad, and we're going to wait for exactly the same amount of time in exactly the same way. Okay, so again, we finished. Oh, except that we haven't, because we haven't written these 2 functions, tick and cross. Okay, so these are going to look a little bit long, but they're actually quite simple, and they mostly contain stuff you've already seen, so I'll whip through them. First thing is, if we're going to draw a tick, we're going to need to know what colour it's going to be, so let's make a colour. That colour is going to be green for a tick, so we've made a colour. Then we're going to get hold of a number which just helps us know how big things are. So we find out the width of the screen, divide it by 2 and put it into a variable I've just called W. We're going to do almost the same thing for the screen height. Put it in a variable called H. Now here's the meat of it. We're going to make a list called points. And that is going to be a list of lists. So this bracket is where the beginning of the list happens. Remember, lists don't have to have brackets around them. It just helps us understand what's going on. Actually, lists are made by putting commas between things. But we need brackets where we've got grouping. So in this case, we've got a list, and then inside that, we're going to have points. And those points are just going to be lists of 2 numbers. So hopefully this will become clear in a second. So we're drawing a tick. So a tick kind of goes. Where's my finger? A tick kind of goes like. Hang on. How can I do this backwards? It goes like that. Oh, I can't do this. It goes like that. So we need to start off somewhere on the left. So a little bit less than the middle of the screen. So W is about the width of the middle of the screen, but we take a little bit off it. So we're on the left of the middle of the screen. And then we take a little bit off H, which is at the middle of the height of the screen, to move up a little bit. So we're to the left a bit and up a little bit. Okay, then our next bit, the middle point of our tick, the bottom middle point, is going to be right in the middle of the screen. That's why W, we're just using W. And then a little bit down from the middle in terms of the vertical. So a little bit further down, because plus means down on the screen. Okay, and then the next point is going to be further along to the right, but then back up, and in fact even further up than we were at the beginning, because that's the shape of a tick. By the way, you can have this comma or not have this comma. Python doesn't mind. I always like to have it. just in case I add some more stuff later. Okay, so one other thing to notice here, I've added a load of space here. That's just to keep my columns lined up. I like to have everything lined up, you may have noticed. Okay, so once we've got the points on our tick that we're going to draw, we just need to draw the tick. So first thing is, let's make the screen black. Next thing is, you know, at some point I'm going to make a typo during this, and we're going to go off to the bit at the end where I try it, and it's all going to go wrong. Maybe that today will be the day. Scroll up so you can see it. Okay, so this last number is how wide we want the line. So what this function does is, it's called lines. It draws some lines on the screen. So you say, where am I drawing it on the screen? What colour am I drawing it? Well, that's the green colour we made. False means don't draw a filled in shape, just draw the lines. And then points is what are all the points on the line. So you're going to go dot 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 dot, and the places you dot between are going to be stored in this points thing, which we made up here. And then 20 is how thick is the line. So as with everything else, once we've finished drawing, you do a display.flip, and we've finished. So that was tick, let's do cross. It's going to be very similar, so I'll try and rattle through it. I know this is taking a while. So make a colour. This time it's going to be red. And we're going to make the width and the W and the H like we made before, so I'll just copy that down. But this time, cross is a bit easier to draw. It fits into a square, so we're just going to have the coordinates of the corners of a square. So the left of our square is going to be W minus W over 3, so a little bit to the left. The right is going to be W plus W over 3, a little bit to the right. Top is going to be H minus H over 3. You see a pattern here? The bottom is going to be H plus H over 3. So these are just the edges of a square. You know how I said I like to have everything lined up? Well, I really do. Okay, so we're going to draw two lines. The first one is going to go from start 1 to end 1. This goes from the top left to the bottom right. And the next line is going to go from start 2, which is in the bottom left, to the top right. See what I mean? So now, these are, start 1 is a point, whereas left is just a number. So left is an amount of horizontal, top is an amount vertical, and then start 1 is an amount horizontal and vertical, i.e. it's a point on the screen. It's actually just a list of two numbers, but a Pygame treats that as a point on the screen. So, make the screen black. If I can type. Then we're going to draw two lines. So the way you draw a line is like this: Pygame.draw dot line. Where are we drawing it on the screen? What colour are we drawing it? Well, this colour we made, which is red. Where are we drawing it from? Start 1. Where are we drawing it to? End 1. How wide is it? 20 again. Okay, then we're doing another one. Draw a line on the screen in the colour we like, which is red, from start 2 to end 2. Width 20. And then never forget Pygame.display.flip to actually show it on the screen. And if I've typed all that right, we have finished. So let's jump to LX terminal, which I've started up in the same way as I do normally. And I'm going to run the program the same way we do normally. redgreen.py, /redgreen.py. When I run it, it's going to show us a green dot, and we're going to press a key, and hopefully we'll see a tick. Ready? Green dot, press a key, we see a tick! Stays for 2 seconds. Oh,
and then waits for me to press because it's got into the end function, and we're all done. Okay, so let's try again, and this time let's get it wrong. So ready, see a green dot, so we should press. Here it comes, there it is. Don't press anything, and we get a cross saying very bad, you did it wrong. So well done, we've got what you might call a game with feedback for our player, whether they've won or lost. And next time we're going to put some writing on the screen to make it a little bit easier for the person playing to understand what on earth's going on. So, see you then. Hi, my name's Andy, and this is part 9 of my first Raspberry Pi game. We're making a very simple computer game that works on your Raspberry Pi. When you see a green thing, you've got to press the key. We've done that bit. When you see a red thing, you cannot press the key. We haven't done that bit yet. What we're going to do today is just put a few instructions on the screen, and we're also going to practice a technique called refactoring, which is just changing your program without changing what it does. So do have a look at the blog post. I seem to have written a really long one this time. We're not doing that much, but we're changing a lot of functions that are already there, so I've got the whole function written out every time. Anyway, if you look in that blog post, you'll find the full version that you should end up with at the end, which you can check against mine. Okay, so let's have a look at our blog post. At our code as it is at the moment. Now at the moment we do have one piece of writing that we write on the screen. This time we're going to make quite a few other pieces of writing. The way we're going to do it is take the code we've already got to write on the screen, remodel it a bit, and then reuse it. So the first thing we're going to do is refactoring. What refactoring means is changing the structure of the code so that it's in some way better without changing what the code does. We'll find the pieces of code that write the text, and we're going to extract them out into their own little function. So the pieces of code that write the text are this bit here, which makes a font, and then renders that font into an image, which is the image of the word ready written inside a rectangle. And then in another piece of the code, we work out where we're going to write this text, and then we write it onto the screen. We're going to combine those two pieces together. So, where are we going to put that? We're going to make a new function. We're going to call it write text. I'm going to put it right at the top here. So, write text. Now all it is, oops, 1, 2, 3, 4, is take the stuff that we had before, and put it all together in here. Like so, and we need to call this function from somewhere, and where we're going to call it from is the second place where we had code before. We're going to call it from here. So now ready screen, when it wants to write ready, it calls write text, and write text does all that stuff that we used to do. So the observant among you might notice that this is slightly different in meaning, because this creation of this image is going to happen every single time we call write text, and not just once when we called start like it would have done before. If we'd called ready screen lots of times, which by the way we're not doing it, but if we had called ready screen lots of times, we wouldn't have had to do this rendering part lots of times. Now at some point we may change it back again so that we only ever render something once, but what I've found is it doesn't take that long to render, so I'm fine with that. Anyway, what we've done is we've changed our program, and restructured the way it works, but it still does the same thing. So let's save our program and let's try that out. So /redgreen.py. If we've done it right, it'll work exactly the way it used to work. So we'll see ready written on the screen. And there it is. Still works. Okay, so that's refactoring. We're going to do a bit more of it now. What we're going to do now is this function is not actually very useful, because all it does every time is it writes ready on the screen. So we're going to make a few changes to it to make it better. First thing we're going to do is we're going to rename ready text. We're just going to call it rend, because I couldn't think of a better name. So rend, everywhere we use it, we rename it.
So now it's called rend, and the next thing we're going to do is, instead of this function always writing ready, we're going to take in some arguments that tell it where to write, what to write, and what colour to write it. So, what screen should we write it on? What writing should we write, and what colour should it be? Notice I always spell it the American way when I'm writing code, because otherwise I get confused between... Sometimes you have to spell it the American way, sometimes it's your own variable name, so you wouldn't have to. I just always do. You can do what you like, but I try and avoid confusing myself wherever I can manage it. So, what I'm doing here is I'm changing this code, so instead of using the hard-coded stuff we were doing before, which was that it always drew it in white, and it always wrote ready, now I'm using these arguments of text and colour, and I'm using the screen one that is actually already globally available, but I'm now passing it in. But while I'm here, let me get rid of this. We don't need that ready text anymore, because we're only making rend inside here, and we're never reusing it. So, in our ready screen, oh, and look, we don't need it there either. Okay. In our ready screen function, we call write text, we pass in screen, which is globally available, we pass in ready, which is the writing, and look, I was clever and I copied and pasted that pygame.color white so I didn't have to type it again. So when we want to write text, we can now say, I want to write it on the screen, this is what I want to write, and this is what color I want to write it. And the write text function takes in that stuff and uses it to do the writing. So let's just check that works again. So again, what we've done is we've refactored our code, but it should be behaving exactly as it did before. And it does. And a note to those who are watching this who know a little bit more about refactoring. Normally when you talk about refactoring, you talk about it in the context of writing tests. I 100% agree with that approach. I'm not writing tests in this tutorial because I thought it would just be too much to handle all in one go. Maybe you disagree. Okay, so next thing I'm going to do, just to make life tidier and easier, is I'm going to take this and put it in a variable called white instead of making it in the middle there. It just makes the code a bit shorter. And I'm going to save it. And again, the program will still work how it used to. Now I've got one more change that I want to make, and that is I want to be able to writing either big or small. And I want to use the same function to do both things. So what I'm going to do is I'm going to make an argument in the write text function called big. And if the writing is going to be big, you're going to say true for this, which means yes, I want it big. And if not, you're going to pass in false, which will write it small at the bottom of the screen. And what I'm going to do is I'm going to do an if, just like the ifs we've seen before. And if big is true, we're going to do this stuff. And what we're going to do is this. We're going to get hold of a thing called height. Oh, in fact, and that height is going to be this, the height of the font. So I'm going to take it away from where I'd written it there, and instead use this variable that I've made here. So I'm making a variable called height. If we're saying big, then height is the screen height divided by 5. And just to make it make it a little bit more flexible, this write text function takes in what screen it's writing on. So we don't know for sure that the screen it's writing on has this height, screen height here. So instead we're going to use screen, the screen that's passed in, and say give me your height, and then we're going to divide that by 5. And then we're using that height to know how big we're doing the writing. Okay, makes sense so far? The next thing is how far up the screen do we want it? And here, previously, how far up the screen we wanted was got from here. So let's move that out and put it up here, and just use that variable that we've made here. Okay, so now when we call write text, we have to pass in this big. So write text is called down here, and we're going to say true because we want this ready text to be big and in the middle of the screen. Okay, once again, let's try our program. And it should still say ready in the middle of the screen, and it does. Brilliant. So again, you might be asking, why are we doing all this work and nothing useful is happening? So let's finally get to a bit of code that does something differently if you pass in a different argument. So 1, 2, 3, 4. Now if 1, 2, 3, 4, 1, 2, 3, 4. If you didn't pass in big, you wanted the writing to be small, we're going to have different answers for these variables, different values for these variables. And what we're going to have is screen.getHeight divided by 12. So small writing is 1/12 of the height of the screen instead of 1/5. And how far up we want it? Well, what we want is we're going to put it at the very top of the screen and then move it up a bit, and the amount we're going to move it up is screen.getHeight divided by, let me look it up, 24. So what we're saying is almost at the bottom. So if it was at screen.getHeight, that would be right at the bottom. That would be right at the bottom of the screen. If we said screen.getHeight, we would be writing halfway off the bottom of the screen. So what we say is move it up a bit, and the amount we want to move it up is the screen height divided by 24, which notice is half of the height of the writing. So we're saying that put the middle of it half of the height of the writing above the bottom, which means that basically it's written at the bottom of the screen. So now if we pass in, if we say that big is false, we get into this half of the if, and we put our writing at the bottom of the screen and smaller, because this we're dividing this number by a larger number. Okay, so again, no, let's not try it out again because we haven't actually done anything interesting. Let's make use of this. So what we're going to do is we're going to find the green shape, and what we want to say is when there's a green shape showing on the screen, we want to say to the player, press a key, so that they know what they have to do if they've never played the game before. So what we're going to do is go to the green shape function and say write text, write it on the screen just like before, and we're going to say press something, and I've lost my place, hold it, I've got my notes over here, I'm desperately trying to find my way through. And we're going to say write it in black, pygame.color black, and we're going to say, instead of true like we said before, we're going to say false, which means write it small, not big, because if it's true that means big is true, that means write it big. If it's false that means big is false, which means write it small. So we're going to say write text, and what we want to write is press something, we want to write it in black, and we want to say write it small. Okay, so let's try that, shall we? Save it, run it. So now we've written our reusable function, we get to use it. So it says ready just like it did before, but now when it shows the green, it says press something. And we didn't press anything, so we failed. Okay, so you see how because we've written this reusable function, we get to use it again. There's a lot less work writing that text than it was writing our first bit of text, I think you'll agree. Okay, so the next thing we want to do is we want to write something if you succeeded or if you failed. So what we're going to do is we're going to go to the green success thing, and we're going to write something about how well done you pressed a key when you should have done. But the first thing I'm going to do is I'm going to look at this tick function, because what tick does is draws a load of stuff, and then it does a pygame.display.flip. But I don't want to do a pygame.display.flip at the end of here, because I've got more stuff I want to do after I've drawn a tick. So get rid of that, and instead, after we've called tick, we'll put it in here. I'm going to do exactly the same thing for cross. This function here is cross. Get rid of it from here, and instead do it just after we've called cross. So exactly the same effect as before, but we can put something in here in between, and that's what we're going to do. So let's get hold of a couple of colours. We'll have a green colour, and we'll have a white colour. We're going to use these to write some stuff on the screen. We're going to write two things. What we're going to write is, you know what, I just had a thought. If I make my notes a bit smaller, I won't have to scroll around so much. There we go. Okay, so we're going to write some text. We're going to write it on the screen like we always do. We're going to say well done in big. And in green. So true means big. And we're going to write something else as well. We're going to write you pressed on green at the bottom in small. Exclamation mark. And we'll write that in white. Okay. Then we're going to do something very similar down below. So let me copy it. So copy. Go to here. Paste. But this time we're going to write something in red. So let's make a variable called red instead of one called green, and let's fill it with the colour green, and then we're going to write stuff in white. And what we're going to write is at the bottom we're going to say bad luck. For some reason I've got a capital L in my notes, so I'll leave it the same. And we're going to explain what you did wrong. Green means press something. Okay. Now the only other thing we need to do is we need to move our tick, because we've got some writing here that says well done, or some writing that says bad luck. We need to move our tick and our cross up, otherwise they'll be on top of each other. So the way we can do that is the middle of the cross is here. So if we say, instead of halfway up the screen, if we say just a quarter of the way up the screen, and here we do the same thing, just a quarter of the way up the screen, then our tick and our cross will appear in the right place. So let's try that while we're there. So it's going to say ready. It's going to say press something, and let's do it. And when we do it, it says well done, you pressed on green. Brilliant. Now let's try one more try, and this time let's not press on anything. So ready. Don't press. Bad luck. Green means press something. So everything's working as we expected, which is amazing given the amount of work we've done, I must say. Okay, so last thing I want to do in this this session is I want to just say thank you, you finished, because we've been annoyingly having that end function getting called, but it doesn't actually show anything, even though it's now waiting for a key press. So let's just write something. So let's make the screen black. You know how to do that, don't you? You fill it with black. Let's make a thing called white, because we're going to need it for our writing. I'm going to write a couple of things in white here. First thing is write it on the screen as per normal. Thanks for playing. It's polite, isn't it? Write it in white, write it big. And we're going to write something below as well, telling you what to do next. Press a key to exit. You can click the mouse as well, but we won't bother saying that. It just seems like too much. And then once we've done any drawing on the screen, we have to do pygame.display.flip. So let's save that. Let's run it, and this time, this is all we're going to do this session. So we've taken the code that told us to get ready, put one piece of writing on the screen, and we've made a function which can do all kinds of different writing. It can write different words, and it can write them in different places because of the different arguments you pass in. So we're reusing that one piece of code that was for one piece of writing to do loads of different types of writing. And the beginning of how we did that was this thing called refactoring, where we changed the program but didn't change what it did. And the really nice thing about doing that is you know absolutely for sure whether or not you've done it right, because you can try it out and it acts exactly the same as it did before. That's particularly good when you've got tests, because you can run all your tests and all your tests should pass exactly as they did before, because none of the outside behavior of the program has changed. And it's a really good way of getting from where you are to where you want to be in a way that doesn't get you too confused or too the programs have this expression like fixing a car. If you take it all apart, you get all the pieces all over the floor, then you have no idea how to put them back together again. And that, if you change everything in your program and don't take everything apart, break everything, and then expect to be able to put it all together and it all works, well, it's a big job, and you won't do it as well as you think you're going to do it. If you go very, very slowly, one tiny piece at a time, and wherever possible, make the changes which change the structure of your program without changing the behavior of your program. And once your structure's changed and everything's all right, you can then change the behavior of your program in a nice, safe environment because you're not changing any structure. Your life will get better, believe me. Anyway, so we've got some good bits of writing on the screen. I think it's absolutely time we drew a red square and told you not to press a key when you saw a red square. So that's what we'll do next time. See you then. Hi, my name's Andy. This is part 10 of my first Raspberry Pi game, in which we create a very, very simple game which will work on your Raspberry Pi. It would also work on very similarly on any Linux computer, and you can also make it work perfectly easily on Windows, but I'm not covering that. Please do have a look at the blog post where I explain everything in more detail, or at least in a way that's written down. Hopefully make it a bit clearer, and it also at the bottom here you can see you can get jump to my version of this code just to check yours against what I've done. Okay, so back to the Pi. As ever, we're using LeafPad to edit a program called redgreen.py, and we've also got LX terminal ready to run it when we get to that point. Just a quick reminder that our program looks like this. There are some main functions which explain what it does. So we start, we show a screen that just says get ready, then we wait, and we wait for an uncertain amount of time just to make sure it's not too easy. Then we show the person who's playing a shape, and if it's a green shape they're supposed to press a key, and if it's a red shape they're not supposed to press a key, and then basically we finish. And that's the structure of our program at the moment, and today we're going to look at the shape function, because you know I said we show a green shape or a red shape. Well, actually we don't, we always show a green shape, and today we're going to change that. So let's find this shape function, which at the moment is extremely simple. All it does is show a green shape. Today we're going to make it clever enough to show a red shape or a green shape at random. So first thing we're going to do is we're going to need two numbers that are going to be a convenient way of talking about things. So 1, 2, 3, 4. Because we're continuing this function, we indent to the same level as the other stuff in the function. And we're going to make a variable called green. I'm giving it capitals because it never changes, and it's a fairly common convention to set something that never changes to be all capitals. 1, 2, 3, 4. And we're going to have another thing. We're going to call it red. I put the extra spaces in here just to make things line up. It doesn't change anything, just makes it look nicer to me. So basically we've got two variables which don't vary, so we call them constants, although in this case they're just variables that I've given a name with capitals, and they're two different numbers, and actually it doesn't matter what they are. I've made them 0 and 1. They could be anything so long as they're different from each other, because the way we're going to use them is this. We're going to say, tell me which shape I should be showing, and the way we do that is we use the random module, which we already imported at the top because we were doing other stuff. And in the random module there is a function called choice, and what you do is you give it a list. So this square bracket means we're making a list, making an array actually. Is that right? Yeah, I think that's right. I'm trying to remember the terminology in Python. Anyway, we're giving it a list of things, and the list we're giving it is green, red, which remember it's actually just 0, 1, but it just helps us to give them names. And what we're saying is choose one of these. So this choice function chooses one of these two things and puts the answer into shape. So now shape is either green or red. It's either 0 or 1, but we're going to call them green and red because it makes it easier for us to see what's going on. So once we've got this answer of either green or red inside the shape variable, we can do something based on it. And what we're going to do is this. If shape is green, colon, 1, 2, 3, 4, 1, 2, 3, 4. So that extra level of indentation we've done there means this stuff only happens if this if part was true. So if the shape was green, well, we do what we used to do. Let's just put that there. We call our function called green shape. Otherwise, 1, 2, 3, 4. You may be able to predict this. If shape's not green, it must be red. So what we're going to do is call a function called red shape, which we haven't written yet. So let's go and write our function called red shape. Just above the shape function here, we're going to make a new function, red shape. and it's going to look quite a lot like green shape. So if we ever look at green shape, what that does is it basically draws a circle, writes some writing, does a flip which tells you display what I've been drawing, and then it calls shape weight, and then it does something based on what came back from shape weight. We're going to do something really similar to that, but instead of a green circle we're going to do a red square. So first we'll get hold of a colour, pygame.color. So you can see this is very similar to what we had up above. Get me red and put it into that variable called red. And now we're going to draw a rectangle, so it's going to be slightly different from what we had above. We need the height of that rectangle, that square rather. So let's make the height. The height of the screen divided by 3 multiplied by 2. So 2/3 of the height of the screen. Where we're going to put it is going to be the width of the screen divided by 2 minus the height divided by 2. Just move me out of the way because I want. No, that's alright. Let's scroll up. You remember what that other one looks like. Okay, so these are just numbers that I've found that made it look nice. Puts it in the middle of the screen, I think. I can't remember the maths I did to get to this point. Screen.getHeight divided by 6. So if we put it there and we give it that size, it looks good to me. So first thing we do, let's colour the screen in white. So you know how to do that. Notice that here I'm using pygame.color directly. But up here I made a variable called red. You can do either of those things. Normally what changes it for me is if my lines get too long, I break them into multiple lines. So nothing too clever. So now that we've got the screen filled in white, we can draw a rectangle. Where do we draw it on the screen? What do we... hang on, yeah. What colour is it? Red. And then what is its shape? Well, you give its left, its top, and then its width and its height, which are both going to be height because it's a square. And then we're going to pass in a 0. I can't remember what that does, something else that we don't care about. And we're also going to write something on the screen. So where we're writing it is on the screen. What we're writing is don't press, because we've drawn a red square, so don't press anything. And the colour of that writing is going to be black. Like so. I'm going to pass in false, which means write it small at the bottom of the screen, if you remember. So that's all making me think. The fact that you have to remember false or true, and it's a bit tricky, makes me think that I probably should have written that write text function in a way that makes it easier to understand. Anyway, that's how it is now. We remember because this program's not too big, but if I was writing a larger program, I would definitely change that to make it easier to understand. I probably should do it anyway, but I don't want these videos to go on forever. At some point I do want you to finish and make an actual game. Okay, so we've done a pygame.display.flip, which just says display everything that I've drawn, and then we're going to call the shape weight function, which is a function we've already got because we do something almost identical in the green shape function. So basically we wait either for the person to press a key or not press a key, and the answer we get back is yes or no, did they press a key? So we need to react to what they did in the right way. So if they pressed a key, well, before, when we were in the green shape function, pressing a key was a good thing. Here it's a bad thing because you're not supposed to press a key when there's a red square showing. So what we're going to do is we're going to call this failure function, which we haven't written yet, red failure if you did press a key, because pressing a key was wrong. Otherwise, we're going to call red success because not pressing a key was right. And that's the end of our function. All that's missing now is these two functions, red failure and red success, which we haven't written yet. So, how are we going to write them? Well, they are going to be surprisingly similar to these two functions up here, green success and green failure. Not quite similar enough for me to end up turning them into one function with different arguments passed, although there's definitely an argument for that. But similar enough for me to copy them and paste them. So let me show you what I did then, because I was doing it with the keyboard. So select them. All I'm doing is obviously a copy and paste. I just want it to be visible on the video. So copy it, paste it. So now I've got green success and green failure twice. So let's call this one red success and this one red failure. So the first thing that we do when we get to a success screen is we draw a tick. Well, that's still the same. And we make some colours, green and white, and then we write some writing. And the green success one says you pressed on green, but that's not right. But what we can say is you didn't press on red. Well done. Still say well done. Notice we've still got our bug here that you can't exit while it's displaying this message. We are going to fix that soon. Okay, so let's look at red failure. So red failure writes the writing in red and it says bad luck. So bad luck's still fine, but now we should say something that explains why that was bad. Red means don't press anything. Still white, still written small, still got our bug. But now we've written those two functions. So basically, if you didn't press on red, we say, well done, you didn't press on red. If you did press on red, we say, bad luck. Red means don't press anything. So hopefully you understand what you did wrong when you get it wrong. And next time you play, you'll understand it. Okay, so I believe we've done enough for our program to work. Let's try it. ./redgreen.py. Whoops. ./redgreen.py. Ready? Go. Let's see whether a red square appears. No, it was a green circle. Alright, let's try again. We might be here a while. This is all live. It's the joy of live television. Oh look, it's our first mistake. Let's see what we've done. Okay, oh I see what I've done. So what it's telling me is on line 164 I've made a mistake, and I can see the mistake. Can you see the mistake? I was trying to call the getWidth function and then divide the answer by 2. Let's have a look at line 164. So that error message was saying line 164, and here's line 164. And what I've done is, instead of calling the getWidth function, I'm just talking about the getWidth function without calling it. The way you call it is you put bracket bracket. So that's a classic typo that you may have made before now. And not understood what was going on. But what happened to me then was that error message pointed me to the line of code. I didn't really read what was this stuff about what I did wrong, because it was confusing. It often is. What I did was I saw the line number, I looked at the line, and I thought, alright, I know what's wrong with that. And that's often what happens. Okay, if you want to get rid of all that stuff off the screen, just type clear, and then we can run it again. Let's see whether it works this time. Notice, by the way, I didn't see that error until it tried to show a red square. Oh, there's a red square. And look, it says, well done, you didn't press on red, so we've done it right. Let's try again, and this time let's press on a red one if we can. Just to check the other thing works. We pressed. Red means don't press anything, bad luck. Okay, it's all working, and we hopefully, the green circle stuff's still working as well. Let's assume it is for now. I suggest when you do this that you check everything works properly, but I won't waste your time on the video. Okay, so we've got it. We've achieved our objective for today. The only other thing I wanted to do was I've actually found a bug since the last video that I think we should fix, and now seems a good time because it's a very quick fix. So let's try something else out. Let's run it, but while the ready screen is visible, let's press a key and see what happens. So I pressed a key while the ready screen was there, and look, that key press shot through into the red square that was displayed. And that's wrong. Basically, I think it should throw away all your key presses as soon as it shows that red square, and then only listen to what you're pressing right now. So there's an easy fix for that, and we used to have a fix like this in our code, and somehow I managed to lose it along the way while I was moving things around. So I've explained this before actually. 1, 2, 3, 4. So all we need is a line that says pygame.event.clear, and we're in the shape wait function, which is where we're about to start waiting for the person to press a key because there's a shape showing. And just before we start waiting, which all happens down here, I just want to say clear all your events out. So anything that's happened before, I don't want to know about. I only want about stuff that happens from now on. So add that line, click save. This time I'm going to press a key while the ready screen is visible, and hopefully nothing will happen when the shape appears and I get a chance to press a key again, or not. So ready, press a key, but this time it doesn't screw me up. And in fact, I don't press the key on green, so I've done badly. Okay, so that was just a tiny little fix that we needed to do. And other than that, well done. We've finished our work for today. Now we've got something that you could almost call an actual game that you might want to play. You can test yourself to find out whether you are quick enough to notice a green shape and press the key, or a red shape and not press the key. If you want to check your version or you've got problems, do check the blog post on artificialworlds.net/blog, where there's a full version of my code. You can compare it against yours. We've only really got two things left that we need to do. First thing is, you know that bug that I've been talking about, I've been bugging you about, which is that you can't exit while we're displaying a message to you. Well, we need to fix that. It's no good. It's too rude. And while we're doing that, hopefully we'll learn a little bit more about refactoring, and we'll at least have another example of refactoring our code, because we'll take some of our existing waiting code and we'll combine it with the kind of waiting code we need in that case. And hopefully we'll do that with a bit of refactoring, or at least with a bit of jiggling around functions. And then finally, after that, what we want to do is, instead of just playing the game once, which is what we've got down at the bottom here, just running through it once, what we actually want to do is show you several different shapes, count how well you're doing, and give you a score at the end. Once we've done that, we've pretty much finished the game. So maybe there are only two pieces of work left. Can't be sure of that. Anyway, that's it for today. See you next time. Hi, my name's Andy, and this is part 11 of my first Raspberry Pi game, where we write your first ever computer program using your Raspberry Pi or any other Linux computer. It's been a long series. I've been trying to cover things completely with no knowledge required except how to use a computer and type stuff in. This one is part 11, and I'm pretty sure there are only going to be 12 parts. So if you've got this far, well done. Stick with it. We're going to do something that we need to do this week, and then next week we're going to make it into more of a game rather than just a sort of one round of a game. And hopefully we'll be finished. We'll have a proper game that you can play and show your friends. Okay, so do check out the blog post that you can find on artificialworlds.net. It's got everything I'm going to say today written on there in a way that might be easy to understand. It's also got my version that you can click through to and compare against what you've got. So let's jump back onto the Pi. Here's our program that we've written so far, called redgreen.py. We're writing a game that either shows a red circle and you have to quickly press a key, or it shows you sorry, did I say a red circle? It shows you a green circle and you have to press a key, or it shows you a red square and you have to not touch anything. And you lose points if you press on red, and you lose points if you get points if you press on green. Okay, so let's jump in. So what we're going to do today is we're going to fix up a problem that our program's got, which is that there are quite a lot of times where you can't exit. The program's waiting for something to happen, and it's not listening to what keys you're pressing on the keyboard. So we need to tidy that up. It sounds boring, but we're going to be covering quite a lot of things that you need to do when you're writing code that hopefully will help you learn for your next project you're going to do. You're going to need to do similar things. So first thing we're going to do is instead of only listening to one type of quit event, that is there's only one way of getting out of the program, which is closing the window in the top right. We're going to make that a little bit more general, so there are other ways of quitting. The particularly useful thing about this is that if the game was running in full screen, not just maximized, but full screen, so that you can't even see the surroundings of the window, which lots of games run in that mode. you won't be able to close the window by clicking the top left, so you need another way of doing it. And the way I think we should do it is letting you press escape as well, but there may possibly be other ways. If you're running on a different device, maybe you press, if that device has a start button or something, maybe you press that. But anyway, what we're going to do is we're going to go and find the shape weight function. And in this shape weight function, we've got this little piece of code here. Let me change it so you can see the whole of it. Got this bit of code here that says if the event that we're talking about, because at the moment we're in a loop where we're waiting, seeing what events happen. Events are things like keys getting pressed, windows getting closed, things like that. And we're saying if the type of event that we're seeing, that's what event.type means, is this quit type, which means basically someone closed the window by clicking in the top right, then we quit. What I want to do is make this more flexible. So the first thing I'm going to do is I'm going to do a bit of refactoring. By which I mean changing how the program works without changing anything it does at all, changing its behavior. So what I'm going to do is I'm going to make an isQuit function up here. So I'm going to say make a new function by typing def, give it a name which is isQuit, and it's going to take in an argument called evt, which means event. So what this function is a way of asking, is this event that we're passing into you something which should make us quit? So the answer we're using at the moment is exactly this piece of code down here. So what I'm going to do is I'm going to take that piece of code away by cutting it, and I'm going to paste it into this new function. 1, 2, 3, 4. 4 spaces for anything that's inside something else. And then I'm going to paste what I just cut. But that's no good, I need a return. So what I'm saying is, this function just gives you back the answer. Is this event a quit event? And the answer is, if it's pygame.quit, as in they close the window, then the answer is yes. So this will return true because this expression becomes the value true and then gets returned by the return statement. So to leave our code the same as it was before, we need to call this function in the place where we used to have that bit of code. So we're going to say isQuit, and then the event that we're interested in is also called evt here, which is a coincidence. And what we've done is left our code exactly as it was before in terms of behavior, but we've made it more flexible to support what we're going to do next. So before we do anything else, let's just check that we haven't completely broken it, made a mistake, by running the program and seeing whether we see any errors. So to run the program, we type ./redgreen.hide, because that's its name, and we run it, and it runs just as before. And we can close the window by pressing the X in the top right, so that works too. Okay, so the next thing we're going to do is we're going to make this function cleverer, which is the reason behind everything we're doing here. So instead of just returning the answer, is this event someone closing the window by clicking in the top right, we're going to ask a more complicated question. That question is going to take a few lines. It's one logical line of code, so it's one piece of logic, but on the screen here it's going to take several lines. So the best way in Python to let Python know not to stop looking and keep on looking at this line is to make an open bracket, put your stuff on the next line or wherever you want it, and then when you've finished, put a close bracket at the end. So far, again, I haven't changed the program at all, I've just added some brackets, but now I'm really going to change it. And what I'm going to say is, I want either this thing, which is closing the window because you clicked in the top right, or something else. And the other thing I want, I'm going to line it up like this because it just makes me happy. The other possibility I want is that you press the escape key, which is in the top left. On most keyboards it says ESC on it. It just seems a reasonable way to quit. Lots of programs let you press escape to quit. So what we want to know is not just the type of the event, because it will be a key press, but also which key you pressed. So there's two things we need to say, and they both need to be true for us to want to quit. So the first thing is it a key press event? So I'm going to say event.type equals pygame.keydown. But also, I'm typing this AND, which means it has to be two things have to be true at the same time for this to come back as true. So the other thing is the key that you pressed has to be pygame.k under escape. So this k underscore escape is Pygame's way. Pygame has a number in it that represents each key on the keyboard, and they all start with k underscore and then the name of the key. So if it was the A key, that would just be k underscore A, I think. But the escape key has this special name, escape. So what we're saying in this whole expression is there are two reasons why we will say that is quit returns true, i.e. there's two reasons why we would quit. Either this part is true, which means that they clicked the X in the top right, or, and that's what this or means, or the whole of this is true, and the whole of this means the type of the event was a key press, and that's what and is doing there, and the key that was pressed is the escape key. So now we should be able to quit out of the game by pressing escape. I think we better try that. So save it again, go back to LX terminal where we're running our program from, press the up arrow and then return to get the same command as last time. Run it, and then when we get to the shape weight screen, press escape. And it quits, so it works. Okay, so that was quite simple. That means that we can quit even if we're in full screen mode. So the next bit of politeness that we need is allow you to quit even at times when at the moment it doesn't work. So for example, when it says ready at the beginning, at the moment you can't quit during that, and we want you to be able to quit. So what we're going to do is we're going to take this shape weight function, which has been useful but is only useful in one context, and we're going to make it into something that is much more useful in a much wider set of contexts. So first thing to do is some refactoring, so we won't change it at all. We're just going to change its name. We're going to change its name. Oh no, we're not. We're gonna make another function that's got most of this function in it. So I'm just reading my instructions. So go up to before the start and make a new function called timed wait. And actually timed wait is going to be exactly all the stuff that was in shape weight. Okay, so we're just going to select all of this stuff, cut it, paste it up here. So now timed wait is exactly what shape weight used to be, except I left in the description of shape weight here because that's going to remain true about shape weight. We're going to call timed wait here. Oh no. Excuse me. That's not quite right. We need to return the answer as well. So shape weight returns an answer. If we're going to call timed wait inside there, we need to return the answer from shape weight that comes back from timed wait. So that's why we need to return. And our program should work exactly the way it worked before. I'll just save. We'll have one more go. I won't do this every time, it will take all day, but let's do it this time. So shape weight should be working exactly as it did before. The program seems to be working. So again, we haven't changed anything at all, so why did we do this? Well, the reason why we did it is because we want timed wait to be useful for lots of other things as well. So what we're going to say is, instead of just calling timed wait and giving no arguments, we're going to tell timed wait how long we want it to wait for and which events we want it to wait, which events will stop it from waiting. So in the case where we're waiting for the user to press a key, the player to press a key when there's a green or red on the screen, which is what shape weight is for, then the events that we are interested in, we will stop waiting if these things happen. Those things are anything where you press a key, or anything where you press a mouse button. So there's two types of thing that we care about happening. Either the key got pressed or the mouse got clicked. We want to wait for 2 seconds, which is written as 2000 milliseconds, and those are the events we're interested in. So we want to change timed wait. We haven't done it yet, but we're going to change timed wait so that it can take in these two arguments: how long to wait and which things we care about, which events are going to stop us waiting. And I'm just going to add a comment here, because whenever I write a number of milliseconds I find it confusing. So I always want a comment, which is what this bit is, just a comment written to me, the computer ignores it, just telling me how long I mean when I say 2000. So here, 2 seconds. So what we've done is we've optimistically assumed that timed wait has been changed to work like this, even though it hasn't yet, and now we're going to go up and do that. So let's go back to timed wait, and we're going to make it take 2 arguments. And what we're going to do is we're going to be a bit clever. We're going to name these arguments the same as some variables that were actually already created inside the function. So time to wait used to be a variable that we created inside, but I'm just going to delete that line, because now something with the same name, time to wait, is going to be passed in as an argument to the function. And the other argument is going to be event types that cancel. And previously, on the next line here, is where we created that event types that cancel variable, but now we can delete it, because instead of creating it there, we're passing it in as an argument to the function. And you'll notice that the two things we passed in, 2000 and key press or mouse button, are exactly what we used to be set up as the answer in here. So again, we haven't actually changed anything the program does by making this change. It's just that instead of creating them as variables around here, we're passing them in as an argument here. And if I look back at where we passed them in, we're passing in the same values that were used before, because that press event is actually key down or mouse button. So again, we haven't changed anything. Save it. And again, we could try this out and it would work the same as before. I'm going to skip that. We'll be here all day. And the other thing I want to do while we're here is I'm going to copy and paste from a screen you can't see a little bit of description of what this function does. Whoops, see what happened there? I can't do that. I can't copy and paste into here from there. I'm going to type it. So wait for time to wait, but cancel if the relevant event happens. Just to describe a bit about what we pass back as the answer: return true if cancelled, or false if we waited the full time. So let me scroll so you can see it. That's just a description of what we're doing, and all it says is wait for this amount of time, cancel if one of these things happens, and return true, a different answer depending on which one happened. Either you waited the full time or you didn't. Okay, so again, the program's doing exactly what it used to do, but but it's structured in a different way. That means we can reuse this timed wait function for something else, which we will do in a minute. Just before we do that, we've got one other change we're going to make, which I'm not going to explain too much. You can go off and read about it if you want to. But basically, there's this thing in Python and in quite a lot of languages called exceptions. And basically what that means is if something you didn't expect to happen happens, the program stops running normally. You know, we've been used to the program going down, 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 line by line, jumping back up when you've got a loop or something like that, but just going round and round, moving down line by line. What an exception does is it changes that. If something unexpected happens, the phrase that's used is that an exception gets thrown, and what that means is that the program stops running line by line, and instead it jumps out to somewhere where it's come from a long time ago, and there's some code there which deals with that exception. Or if you don't write code to deal with the exception, you end up with the program finishing and it prints out a message saying there was an exception. So I'm not going to say any more about exceptions. You can go and look that up and find out about it. But in order to make this program deal in a reasonable way with exceptions, I need to be polite about the fact that I've set a timer. So if we look at this code here, we set a timer event that's going to fire later, and we tell it when it's going to event and so on, when it's going to fire and so on. and then we cancel that timer. And really, that's fine, because that will get cancelled at the end if it hasn't already expired, unless an exception happened. And I don't want to be so rude that an exception might happen and then later on this event might suddenly pop up. That just seems awful to me. So the way we avoid that is we can put the code that might throw an exception inside its own block, and then what we can say is we can say, even if an exception gets thrown during this block of code, I still want you to do something, and hopefully that'll become clear in a second. So the block you put it in is called try, and we need to indent everything by one more than it was before. I'm just pasting some spaces in here. You could type them manually if you want to. So everything within here, whoops, everything inside this try block, it operates exactly as it did before, but if an exception happens, we're going to jump out of this code. But all we're saying by finally is, before you jump out of this whole function and go back out to wherever you want to go, do something first. And what we want you to do is to cancel the timer. So this finally block means either you get to the end in the normal way. If you get to the end of this block of code in the normal way, run this code. Or if an exception gets thrown and you're jumping out to somewhere else, still run this code. But it won't run this code in that case, because the exception will shoot out, stop us doing the normal thing that we're doing. So this finally is just a way of guaranteeing something's going to happen, even if something unexpected happens in the meantime and we're going off to an error handling bit of code. So don't worry too much about that. Just copy what I've done, or even don't if you don't care. But thinking about what might happen if an exception's been thrown is something that you need to do when you're programming. It's one of the hardest things to do. And trying to give guarantees about it is extremely hard. Okay, so where have we got to? Now we're being a bit more polite about what happens when something goes wrong. So let's go and start using our timed wait function in a few other places where we can improve our behavior by using timed wait instead of having our own code. So let's find the function that we just called wait. So just a reminder before we get into this, the whole structure of our program, if we look right at the bottom, the whole structure is we display the screen saying get ready, then we wait for a certain amount of time, display a shape, and then finish. And the shape wait function that we've been looking at is inside shape. So actually before we get into any of that, we've got this wait, which waits for a random amount of time, showing the ready screen, and then the shape gets displayed. So let's have a look at this wait function, because at the moment you can't quit while that wait is going on. So while the word ready is on the screen, you can't close the window, you can't quit out, and it's very rude. And the reason for that is that we're calling this function called pygame.time.wait, and that doesn't, no events happen while you're doing that, it just waits. And you'll notice we've even written a comment here saying you can't quit during this, because we knew this was a problem. What we can do is we can fix this problem right now by using our timed wait function. So our timed wait function is all ready to use. So we're going to call it timed wait. We're going to pass in how long we want to wait for, which is precisely time to wait, which is this thing we calculate up here. It's a thing we calculate here, which is a random number. So instead of 2 seconds like we were doing before, the reason why we made this an argument to timed wait is so that we can use it with different times. And the time we're passing in here is this random amount of time. And the other argument we have to give to timed wait is which events do we care about that are going to stop us from waiting. Now, timed wait will always stop if you quit by closing the window or pressing escape, so we don't have to worry about that. That's already in place. What we care about is anything else that you might want to stop for. So in the case we were in before with the shape wait function, we cared about any key presses or mouse buttons. They were going to make us stop. In this case, we don't want anything to make us stop except quitting. So what we do, we want to pass in an empty list of things, a list with no items in it. And in Python, the way you make an empty list is this, bracket, bracket. And then we close the bracket, which matches the beginning of the timed wait. So what we're saying is wait for this amount of time, which is this random number we've calculated, and if any of these events happen, then quit early. So basically, never quit early. We're passing in an empty list. So what that means is we can get rid of line 73 now. Instead of using that time.wait function, we're calling our own function called timed wait, and that behaves better. So we're being more polite. Let's just try that out. So save the program, go back to LX terminal, run the program, and I'm going to try and immediately quit when the ready screen appears. It used to not let us do that. Now it should. And it does. So it's already become more polite. We're already doing well. Okay, what should we do next? Just before we do anything else, we're going to reuse that list of events, the mouse press or the key press or the mouse button press events. So there's going to be quite a lot of pieces of code that all want to use this variable here called press events. So what I'm going to do is I'm going to take it out of the shape wait function where it can only be used there. I'm going to put it at the top so it could be used by lots of different pieces of our code. So I've just done a cut. I'll go right up to the top, just after some of our other global variables. Global just means visible in lots of places. I'm going to put it there. So there's this thing called press events, which is key press or mouse press, and now we can use press events in some other places, which we're going to do. And one of the places we can use it is inside shape wait, where we got it from. So we don't need to change shape wait any more than that. Let's have a look at that. So if we look back at shape wait, hang on, have I missed it? Yeah, if we look at shape wait, it's using press events, but press events is already visible to it because we made it up at the top. Okay, so we're going to use timed wait in a few more places, and we're going to use press events as an argument to timed wait. So the first place we'll look at is the end function, which happens right at the end, which just says thank you for playing, and then it waits. And what we've done is we've written quite a lot of code here to say don't do anything until the user presses the key or closes the window, until the player presses the key or closes the window. So actually, this whole block of code that we've written here can just be replaced by a call to timed wait. So timed wait is able to do exactly the same thing as what we've written there without us having to write the code again. So this list of events that cancel is actually the same list as before, so we can just use press events and pass that into timed wait. And the other thing I've done here is I've been a bit clever. I've passed in a 0, which means which I happen to know means that it will wait forever. So this piece of code here waits forever. So what I've said to timed wait is pass in 0, which means wait forever, and pass in this list key down and mouse button to say that those are the things that make you stop waiting. So I've done something equivalent. Now the question that may remain in your mind is, why does passing in a wait time of 0, i.e. don't wait at all, actually wait forever? And the answer is slightly subtle, so let's have a look at it. Let's go back and find timed wait. I'm getting bored of scrolling around and looking silly, so whoops. So let's use the find function. There we go. Oh, that's good, wasn't it? So don't worry about the yellow. That's just leaf pad highlighting the thing I searched for. So the reason why, if you pass in a 0 here, saying wait for 0 milliseconds, the reason why that waits forever is a bit subtle. What it is this line here where we set a timer. We give the ID of the timer that we're interested in, and then we give the time to wait until the timer fires. But the set timer function, if you pass in 0 as the time to wait, doesn't wait at all. It doesn't even set up the timer. In fact, it cancels the timer if it exists. But if the timer doesn't exist, it doesn't do anything at all. So if we pass in 0 here, it passes in 0 here, no timer event gets created at all. So this part will never happen. And when we cancel the timer, which you'll notice we do by passing in 0, nothing happens because there's nothing to cancel, and that's fine. It doesn't mind that at all. So that's why passing in 0 to timed wait makes us wait forever. Okay, so more places where we can reuse this timed wait function. So we've used it in shape weight, we've used it in end, but the other place we can use it is when you've either won or lost by pressing a key or not pressing a key. At the moment we've got this bug, and we've written a comment about it saying you can't quit or skip. Well, let's fix it. So we call timed wait, we pass in 2000 milliseconds, we pass in the standard list of events, which is press events, which we defined right at the top, and we add a comment saying that you wait for 2 seconds, and when we can delete the way we used to wait because we've got a better way of waiting now. And what I'm going to do is copy that code because we're going to use it in a few other places. So previously we used pygame.time.wait. Now we can do it a better way, still wait the same amount of time, but this time there's various key presses you can use to stop waiting, and also quitting works. So we're actually making our program a little bit better. If you get bored watching that success screen or that failure screen, you can now press a key to skip through it, and that's what this press event is doing. It's passing in a list of things that make it stop. So 4 places, these 4 functions: green success, green failure; red success, red failure, which previously did a rude way of waiting, now do the polite way. And in a minute we'll try that out, make sure it works. Just before we do that, there's a bug that we need to fix. So have a look at the function green shape. There's a place here where I just made a typo. So I meant that the radius of the circle should be 1/3 of the screen's height, and I typed get width. So if we change this to get height instead of get width, the circle should be a bit smaller, and I think it looks a bit nicer. So let's do all those fixes, try it out, and what I'm going to do is I'm going to be running the program and then quitting at various times and checking that it works. So first thing, we've already seen, oh dear, got a bug. Okay. I think I mistyped. So go to the top of the program. I think I typed mouse button when I meant mouse button down. So let's see what happened there. Let's move that so you can see it. So we run it, and it says on line 10 of redgreen.py, this is the line. It says module has no attribute mouse button. So the module is Pygame, and then the dot means look inside Pygame for something called mouse button, and what it's saying is there is no thing called mouse button. And the reason why is because I typed it wrong. It should be called mouse button down. So now I've typed mouse button down, I've saved it. Let's see whether I've fixed my problem. I have, good. Okay, so we've already seen we can quit from the ready screen. We can press a key on there and it says well done, and we can then quit. Oh, and I didn't do that quickly enough. On the success screen where it says well done, I want to quit. So that's the failure screen, but same applies. I've managed to quit from inside there. The other thing I want to show you is that we're now allowed to press a key on that success screen, and it skips through and does the next thing straight away. So press the thing, and we're too bored, so we skip straight out of the success screen, go to the end. Notice now we're on the end page where it says thanks for playing, and it waits forever because we passed in that 0. That's what I was trying to explain earlier. So well done. If you followed all that, you've got a game which is pretty much finished, except it only does it once, and in the next session we're going to make it do it lots of times and tell you your score at the end. So see you then for what I hope is the final episode of the series. Bye. Hi, my name's Andy, and this is the last episode of my first Raspberry Pi game in which we finish off our game. We've been writing a game which shows you either a red square, in which case you should press absolutely nothing at all, or a green circle, in which case you should quickly try and press a button. And previously you've only been allowed to have one go, so it doesn't really feel like a game, it's just a little thing. I mean, it's not going to feel that much like a game anyway, but hopefully just enough to get you started. This time we're going to do it 10 times and then give you your score at the end. So simple as that. Check out the blog post which gives you all the instructions I'm going to give you here, and also gives you a link to my version of the finished program, so you can compare yours against mine. Let's jump over to the Raspberry Pi. So the first thing to do is a tiny little thing that we're going to need. Because we're going to be running this loads of times, there's something missing from the ready screen function that we're going to need. So just at the beginning of the ready screen function, we just need to blank out the screen, because we're going to come into this several times by the end of today, instead of just only coming into it once. If we came into it once, the screen's already black when you start Pygame, but because we're going to go in there several times, we need to blank out the screen just before we write the word ready. So probably should have done that in the first place, but anyway, I've done it now. Oops, I didn't mean to save as. Oops, everything's jumping around. I just meant save. So that's the tiny little thing that I've realised we're going to need. I wouldn't have done it in that order had I not already done this. So let's go right down to the bottom and remember how our program works at the moment. So at the moment what it does is, whoops, something going on with my mouse there. You start the program, which just does some setting up, shows the screen that says, are you ready? It waits for a random amount of time, shows you a shape on the screen and checks whether or not you pressed, and then finishes. So that only does it once, and the bit that we want to do more than once is this bit that I'm highlighting here, ready screen, wait and shape. So first thing I'm going to do is write a little comment in here, just so that so that I remember this is the beginning, and that all the stuff above here is functions that we're going to call. And this is kind of the main program. So what we're going to do is we're going to make a loop, and the type of loop we're going to make is called a for loop. So we'd write for, which means this is a for loop, and a for loop is just a loop which goes through a list of things. So the list of things we're going to have is going to be created by this function called range, and we're passing in the number 10. So what range does is it makes a list of numbers in a range up to 10. I'll go into a little bit more detail about exactly which numbers it is, because you would have thought it'd be 1, 2, 3, 4 up to 10, but actually it's 0, 1, 2, 3 up to 9. But I'm jumping ahead there. Anyway, what we do when we make a for loop is we take for, we give the name of a variable, and this variable is going to get a different number in it every time for everything in the list. It's going to change every time we go through the code. And then we say in, and then we give the list that we want to go through. Then everything that we want to do more than once, we put inside the loop. So what that means is we indent it. If I scroll down, so look, end is not indented. So end will only happen once after this loop is finished. But everything that I've indented is going to happen 10 times. And when it happens, I is going to be a different number each time. It'll start off at 0, and it'll go all the way through until you run all this code again when I is 9, and then it'll finish. And this for loop can be used for any list of things, but the list we're using is the list 0, 1, 2 up to 9, which is what is given back by this range function. You may be wondering why when you ask for 10 numbers you get 0 to 9 instead of 1 to 10. It's fairly common in a lot of programming languages. It feels really natural and right to me, but I appreciate it probably feels a little bit wrong and weird to you if this is the first time you've encountered it. Just go with it. Don't forget it or you'll get really confused, but just go with it for now. Okay, so at this stage we could try it, and we would find that we get to play the game 10 times, and that's it. You see 10 shapes and nothing else has changed. So I won't do that. I'm trying to make this one take a little bit less long than the last video I made. So what we'll do immediately is we'll try and work out how to give you a score at the end. So the score is going to be 1 point every time you get it right, and no points if you get it wrong. So when do we know whether or not you got it right? Well, let's have a look up at green shape. So this is the green shape function, which shows a green shape to the person. All this stuff shows the shape. It says press something, and then you wait until they press something or didn't press something, and then when we get to here, here's where we know whether or not you succeeded. Either we call green success or green failure. So what I want to do is make green shape give back an answer saying how many points you got for doing this. So if we succeeded, we're going to show the success screen, and then we are going to send back 1 point. And the way we do that is we type return 1. If you failed, we're going to give you 0 points, so I'm going to return 0. So what we're doing is making green shape change so that it gives back an answer. And we need to do the same thing for red shape, but they're in the opposite order, so be careful. If you pressed on red, that's bad, so we're going to return 0 points if you pressed, and 1 point if you succeeded by not pressing. So now, red shape also returns an answer, giving you back either 1 point or no points. So where do green shape and red shape get called from? Well, they get called from shape, which is the one that gets called right at the bottom. So, an answer's coming back from either green shape or red shape, and we just need shape to give back that answer to the person that called it. So it's really simple what we do here. We just put return. What that means is take the answer that came back from green shape and just make it the answer that comes back from shape. Simple as that. So where does shape get called? Where are we going to get this answer back? Where we're going to get the answer back is here. So now shape is giving us back an answer. What we're going to have to do is collect all those answers, add them up, and then print them out at the end. So what I'm going to do is I'm going to make a variable. I'm going to call it correct, which is the number of correct answers you got. I'm just calling it correct. And at the beginning, before we go into the loop, correct is going to be 0. You haven't got any answers correct yet. And then when we call shape, we get back some points to add on to correct. So what I'm going to do is, that shape is going to give us back either 0 or 1. I'm going to use plus equals, which means make correct increase by the amount of the number on the right hand side. The number on the right hand side is going to be coming back from shape. It's either going to be 0 or 1. So correct will either have 1 added to it or 0 added to it. And if we go through this loop 10 times, every time you get one right, correct will go up by 1. And if you get it wrong, it won't. So by the end of this loop, the variable correct will have the number of times you got it right. So what we're going to do is we're going to pass the answer on to the end, to the end function, and the end is going to print it out for us. Okay, so let's go and find end. We're going to make it print it out in 2 different ways just to help us. So firstly, we're going to write it to the console. So we're using the print command, which writes things to the console. You remember we did that when we wrote our Hello World program in lesson 2, video 2. So here we're using the print statement. We're giving it a string, but we're not just giving it a string. We're giving it a string that we want to process in some way. So before it goes to print, it gets processed. So what happens is, a really nice thing you can do in Python is you can write a piece of text, and at any point in that text you can put this %d, and then you use the % operator. So the string goes in as the left hand thing, and then you put %, and then the right hand thing is some value, in this case a number. So when it's a number you put %d, and % means take this thing you've got on the right and substitute it in to the string that you've got on the left. And if you put %d, that means it's going to be a number. You could also use a %s, which means you're going to substitute one string into another one, which could be useful if you wanted to say hello Andy instead of hello world. And you've got the name Andy from somewhere else. You might want to substitute a string into a string. In this case, we just want to put in a number. Excuse my coughing. So we do %d, and then we substitute the answer correct into here. Now, we haven't actually been given correct yet because I've missed that bit. So notice when we called end, we're now passing in an argument, but I haven't put that in here. So let's put it in now. So now end accepts this argument, which we're already passing to it, and we can use this argument value to substitute the answer into this print statement, and then it's going to print out you got 3 correct answers, or however many you got. Now the next thing to do is we're going to make another string to write on the screen. We're going to call it message. We're going to make a variable with it in, and this is what we're going to write on the screen. So again, we're using a %d just like above to substitute the answer in. Then we're going to say press a key to exit, just like we did before. And we're going to substitute in correct. So we're doing exactly the same thing as before. We've got a string. We use the percent operator. An operator is a thing like plus or minus. It's just something goes in between two things. So we use the percent operator. It takes in a string on the left. It always takes a string on the left. And it takes this number on the right, and the number gets put in there. So all we're doing is this message that we've created, we're now going to substitute in. We're now going to put in to the write text command. Instead of having that string written directly in there, we're making the string on the line before and then passing it in to write text. That's just because it doesn't fit really, no other reason for that. Okay, so now we've changed end. That's the last thing we need to do to be able to print out a score at the end. So let's try that out quickly. So let's run our program the usual way, going back to LX terminal, type redgreen./redgreen.py, run. I'm going to have 10 goes, so I'll go as quickly as I can. So I'll get them all, I'll press on everything just to make it go quicker. So red is wrong, so 0 points. Got it wrong again, still 0 points. Got it wrong again, still 0 points. We've had 3 goes so far. Got it right, we've got 1 point. Got it right again, got 2 points. Got it wrong. Got it right. That's 3 points. 4 points. Still 4 points. Still 4 points. And look what it says. It says, thanks for playing, score 4. Press the key to exit. And look, you got 4 correct answers. Go us. And we can press the key or click to exit. We can see it printed out there. So that all worked brilliantly. Well done us. Okay, so the other thing we'd like to do is we'd like to know the score partway through the game, and we'd like to know how many goes we've had so far, because it was quite hard to keep track, wasn't it? So let's find the ready screen function, because that's where we're going to write on what go we're on and what our score is at the moment. So what we want is someone is going to pass in these arguments to us, go number and correct, which is what we're calling the number of correct answers you've got so far, or your score. So someone's going to pass these in to us. We're not sure who yet, but we can ignore that for now. We know we want to write those things on the screen. Previously we just wrote ready. Now we're going to say this. Instead of just saying ready in the middle, we're going to say what turn we're on and what score we've got. And again, we're substituting things into strings just like we did before, but this time there are 2 of them. So we're using percent, and then instead of just having a number on the right, we've got 2 things to substitute in. So what we can do is we can provide a list, and so long as the list has got 2 things in, and there are 2 things needing to be substituted, that will work fine. It will substitute them in order. So the 2 things we're going to substitute in are going to be go number and correct, right? Well, wrong. So let me just explain. Oops. So we want to write turn, which is go number, and score, which is going to be this correct thing. So it all looks right. The difference is, you remember I was saying when we do a for loop, we start from 0 and go up to 9. Well, that's all very well for us, but when we're showing the person playing the game, they don't want to know they're on go number 0. They want to call that go number 1, and they don't want to think that they're on go number 9 when actually they're on their last one. So what we do is we do a +1 to this number, because the number that's going to get passed in is going to be a 0 for the first one. We want it to be a 1 for the first one, so we just add 1, put all that in brackets to make it easier to understand. And then there's another set of brackets around, which means this is a list. If we don't put these brackets here, this is an example of when it doesn't know it's going to be a list. So we have to put the brackets to make sure it knows to group these things together and treat them as a list. Anyway, we substitute in what turn you're on, which is go number +1, and your current score, which is just correct. So now we've got a string, which is the thing we want to write on the screen. We haven't written it yet, so let's write it. So we're going to write it on the screen. What we're going to write is the thing we've just made, and what colour we're going to write it is white. And we're passing in false because this is the small writing, not the big writing. Okay, So now we've written that on the screen. But where are we calling ready screen from? Because we're not yet passing in the right numbers. Well, let's go find it. We're calling ready screen right at the bottom, down here. And what we're going to pass into ready screen is I and correct. So you know what correct is. Correct is the number of correct answers so far. I, you will remember, is this variable here that we defined, which gets a different number from this list every time. So the list goes 0, 1, 2, 3, 4, 5 up to 9. The first time we run this code, I is 0. The second time we run this code, I is 1, and so on. So the first time we call ready screen, we're going to pass in a 0. The next time 1, and so on. Which is why we're adding 1 to it, to make it look like a more human readable answer inside ready screen. Maybe I should have added 1 here, but I didn't. Okay, so what else was I going to do? Okay, and I reckon if I've done everything right, we have basically finished. Let's try it out one more time. It's a bit boring going through 10 goes, but we'll see if we can manage it. In fact, we might skip it. So look, turn number 1. Oh, did you miss that? Let's do it. Let's do the next one. Turn number 2, score 0. Whoops, when we press something, we say we're now on turn number 3 and we got a score of 1. Press something again, turn number 4 and a score of 2. And again. Our score's going up, it's telling us what turn we're on. We pressed so our score didn't go up. We're on turn number 7. Let's go all the way to the end now, shall we? Turn number 9, still score of 3, and again, when we find the final score, it's going to be 3, and we print that out to the end. So you see, we've basically finished. Well done. So now we have an actual game where you can try out your skill against the computer and find out your score at the end. The only other thing we need to do to get this completely finished, we may as well do it, is to do something that most games do, which is to fill up the whole screen instead of being in a little window like that. Sometimes I hate this, sometimes I like it, but let's just show you how. What we do is just this. We go to the start function here, and in the bit where we're setting up our screen, saying what screen mode we are, we set the size, but then if we put a comma and type in pygame.fullscreen, that means use the whole screen instead of just opening in a window. So let's run our program one more time and try that out. And this is the case where, well, let's run it. This is the case where we really need the escape key to work to exit, because you can't close the window anymore. So here we are, filling up the whole screen. Interestingly, it's not stretched to actually fill up the whole screen, which it does on my main computer. I don't know why on the Pi it's acting differently. Anyway, we filled the whole screen, but if we want to exit, we can't. There's nothing for us to close in the top right. So instead of that, let's press escape. And it works, and well done. We have finished our game. We've got something that potentially could be fun to play. You can compare your version against mine by going to the blog post, which is linked in the show notes on the YouTube video. You go down to the bottom here and click on redgreen.py, and you can compare what you've typed with what I've typed. I also tell you on there that I've actually slightly extended this game for my own fun. I played it with some of my friends, and to make it a bit more fun for grown-ups, because it's more of a kids game, or even just too boring for kids. But anyway, to make it a bit more fun, I made it test your reaction speed and give you a score based on how quickly you pressed on green, rather than just whether or not you pressed. If you'd like to have a look at that, follow this link on the blog here that says Red Green on GitHub. You can download the code from there. Let's have a look at that, actually, shall we? I'll just show you what you can download. So if you click on the file redgreen.py here, you can actually download this file by clicking on raw or something like that. You can also see just a little bit of notes that I wrote about it. If you'd like to make this game even better, feel free to branch it on GitHub and make a pull request. That would be a lot of fun. At some point in the future, I might even do a YouTube series about how to make this game work by lighting up lights and letting you press buttons on a real physical thing instead of just on your computer. I'm looking at whether I can do a series about electronics. That might be quite fun. Other things you should look at the main page of my blog, and you'll find some links to some other stuff about me. There's an RSS feed for the blog. You can follow me on Twitter. You can go to my YouTube page and subscribe. Here's the Twitter page, mostly links to blog posts. Occasionally I dally into a little bit of frivolity. Here's my YouTube page, maybe you've seen this already. You can see my feed, you can see the playlist, which have got the whole Raspberry Pi game thing and the other series that I've made. You can subscribe on there. What else to say? Thank you very much for watching the series. Very well done if you've made it to the end of the series. And do send me comments, do subscribe, and hopefully there'll be other series on different topics. Some of those topics are going to be, I hope, really highly technical, not for beginners, but really hard stuff. But I've really enjoyed doing something that's aimed at people who are just getting started. So maybe I'll do some more series on that. Do let me know if you enjoy.